So,
all right. Well,
welcome again, everyone. Thank you so much for joining us this weekend. We are so excited to have this opportunity to work with you guys. We feel that this is a very special workshop, this particular session, because officially more than half of the class is outside of the US. So we just love that we're able to facilitate this, community between different cultures and different places in the world. And we would just love to hear about materials that you all have found and that you're experimenting with in your studios. And
yeah, I think so. This is our fourth or fifth online intro to local materials classes we've done over the past year and a half, and they've just been really exciting. I think a lot of the participants often share this feeling of feeling somewhat isolated within their community, just because they, not many people are using local materials with such a intense dedication as all of us here today. And so I think there's often a little bit of a difficulty to kind of fit into a community within people who are using commercially prepared materials and maybe just don't share the same philosophy. So our goal is to really create that community for everybody worldwide, where we can all kind of come together over the shared interest in geology or just nature, regardless of how scientific you want to be. We're happy to sort of be a part of this together.
Yeah. So we'll start off with some introductions here today. I'm Zoe Powell. I use she, her pronouns, and I am half of the Studio Alluvium team based out of St. Paul, Minnesota.
I'm Mitch Iberg, he, him pronouns. I'm the other half. Yeah.
Yeah, I'm gonna, in the chat here, just pop a brief description of what we're kind of hoping to hear from people during the introductions. Because of the class size, we'd like to keep everyone's introductions to around 2 minutes or less. You don't have to use up the full 2 minutes if you don't want to. But if you feel comfortable sharing your name, your just general location, that can be useful to find if there's somebody who's located near you who you guys might want to meet up after the workshop. And then just a brief overview of your personal experience using local materials. If you've had a chance to begin testing anything in your studio or not, both are fine. And then also what drew you to this workshop, or what are you hoping to learn from the workshop? So I guess I have a roster here, and of course it's not in alphabetical order, but I'm just gonna kind of call people out, and if you, whenever your name is called, if you want to share, just unmute yourself and let us know. We're gonna mute ourselves whenever somebody else is talking, just to help with the video recording. So I'll start with Naomi Sugihara.
Yes.
Hi, Naomi.
Hello. Hi. Introducing myself a little bit. Okay. Hi, I'm Naomi from Australia, Western Australia. I originally from Japan. I've been working with clay probably more than 10 years, starting with hobby and now taking seriously as a professional. But I've been always interested in using the wider clay or local resources. So I'm really excited to take your workshop today.
Thank you so much.
Thank you.
Yeah.
Thank you.
We're so happy to have you. Did you say 10 years of experience with clay in general or with local materials?
Just general.
Nice. Awesome.
Yeah. I've been kind of like start collecting the wider clay last couple of years, and then not really testing, but just like put in the kiln and then to see what it looks like. So I haven't really start processing yet. Yeah. So yeah, I think this workshop will the chance to start taking seriously using local resources.
Nice. Yeah, that's the best way to start sometimes, is just giving it a go.
Yeah.
Yes. Okay, Lisa Evans.
Hi there, I'm Lisa. I'm in Brunswick, Maine, right on the coast. And I have been working in clay for maybe 20 years, but seriously 8 years, devoted to it. And my interest in the class is I want to try out using the materials on our property we're building, and I'd like to incorporate them into our home. And we have an abandoned granite quarry where we're building, and so it's been fun to start looking at that and experimenting with it. I have used some local materials from other homes that our family has, and just incorporating them into clays and porcelain, and that's been really fun. But that's just an effect. It's not, creating the clay or creating the glaze. So I'd like to just push it a little further.
Nice. Yeah, we love that idea of using a material that you have a really strong connection with. And it sounds like that is what you're doing, using materials from your different homes and really having that strong sense of place to it. So that's so nice. Okay. I'm just going to double check to see if this person is logged in. Not yet. Okay. Ginny Redgate.
Hi. Do I have my video on? I do. Hi, I'm Ginny. I am from Brooklyn, and I've been working with clay for about 7 years. It's my night job. I have a regular full-time job in the tech industry, so it's really fun because it's kind of the complete opposite of the other, it's the analog side of my life. And I am excited about this program, and just in learning, I've grown to really want to progress my work with a greater understanding of my materials. I don't use a lot of glaze. I have had very little experience with local clays. Well, only once, when I was in Mexico, was I able to bring home some local clay from Oaxaca and smuggled that home in my suitcase. But I do have a place up in the Hudson Valley, and so I'm trying to get some people together to go foraging up there. But it's all very new to me. But to me, that's understanding local clays is also just one dimension of just trying to better understand my materials and what I can do to create pieces that are that the material in the clay itself is actually an important part of the the end result.
Nice. Yeah. I love what you say about not wanting to glaze your work sometimes, especially when you are using those local materials. That's something that I do a lot with my work. I will leave it unglazed to really highlight the material itself and to kind of show off all the extra things that I've blended into the clay body. And I think that that's a way of really honoring the clay and where it comes from. So
yeah, it's exciting to learn more about that and to really focus on that as much as kind of or for me more so than like the different glazes I can use on something when it's done or not when it's done, like as if that's what will make it done. But yeah.
Yeah. Awesome. Thank you so much for joining us. Julia or Yulia?
Hi there. So my name is Julia. I'm originally from Slovenia, but I live work in Edinburgh in Scotland. my background is in landscape architecture, and after I finished my degree, I took some time off and did some clay experiments because I really loved clay throughout my life. I was always kind of interested in the material, and it kind of stuck to me. And after a few months, I got hooked, and I've been doing this for about 6 years now. Just recently, so I was sharing my studio for a long time, so I wasn't able to experiment as much as I wanted before. So now that I've moved into my own studio and have control over everything I do and the kiln, I'm able to experiment a bit more. So I'm really keen to learn quite a lot. I've been allowed to use sand in the clay. So whenever I travel, I collect sand and mix it in. So I kind of like that experimental part of what sand does in the clay, and also sentimental part of remembering places where you've been, and different effects that happen in those combinations. But then now I really I've been collecting some clay as well, and I've been really playing a bit with it, but not really knowing what I'm doing. So I would really like to know, loads more. How can I actually transfer into using just materials that I can find in my surroundings? So yeah.
Yeah.
Great. Yeah. The whole sort of like developing the approach to testing things is very interesting. There's, there's people who just prefer to use things in a very simple way, and then others who want to sort of learn more about it and just test it more and more thoroughly. And we like to, sometimes we do things very simply, and sometimes we do things a little bit more complicated than they need to be. But yeah, we just love meeting people who are interested in sort of testing things in varying ways.
Yeah. And congratulations on having a studio to yourself and being able to experiment a little bit more.
Yeah.
I know that's something that comes up a lot in these workshops. People who are using community studios, they find that they get some pushback from the studio owners where they're not allowed to test local materials. So throughout the day, today and tomorrow, we'll kind of give you some like safety tips for how to test materials in a safe way so it's not going to damage your kiln. And maybe you can bring some of these tips to your community studio to say, hey, if I do it this way, there shouldn't be a problem, hopefully. So for anyone who is,
that's perfect. That would be really great.
Yeah.
Looking forward to it.
Okay, let's do Jen Law.
Hi, I'm Jen. I'm joining from Ontario in Canada. I'm primarily a print-based artist, but I've been working with clay for about 6 years. Most recently, I work predominantly in raw or unfired clay. And I have never worked with wild clay or processing earth pigments, although I have used earth pigments that other people have processed. So I'm interested in gathering some clay from our property and working with it, and both with in ceramics, but also possibly using some of the pigment in the clay to mix with some lithography inks later on. So I'm excited to learn more with everyone.
Yeah, that's wonderful. I think you're the first printmaker who's joined one of our workshops and mentioned using the materials as a pigment. But it's true that clay has come in all different colors, and that's one of the things that attracts us to using these local materials is that certain ball clays can be blue or green out of the earth, and you would never find that in a commercially processed clay.
Yeah, it's just wonderful how we can share a material that's has relevance to different fields of, or different genres of art making. So it's it's not just ceramics; it's also painting, printmaking, sculpture,
even dyeing, fabric dyeing.
Yeah, fabric dyeing.
Yeah, absolutely.
Yeah, thank you so much for
thanks,
joining
Jen.
us.
Thanks.
Lisa Viscardi.
Hi, guys. I am Lisa Viscardi, and I've been working with clay for 3 years. I live in Santa Monica, California. Not even 3 years, almost 3 years. And this is my third workshop with you guys. And I'm really just still completely learning, exploring, and I'm very drawn. I don't love glazing things, but there's just so much to say. I'm very interested in the holistic approach, the makeup of what the whole thing is, metaphorically, what it is I'm doing, and how it all fits together. I'm really into building more than finishing, glazing and everything. So I think I'm really into the nature of it. I'm also really into color. And I think it's interesting, not just earth colors or earth pigments, but also mason stains. And I think the juxtaposition is almost expressive of our lives. So I really don't know where I'm going or what I'm doing. I'm just learning. I'm so attracted to what you guys do. I don't know if I have the wherewithal to be foraging clay and doing all of that. But if I just, right now I'm nourishing that aspect of my approach, and I have no idea. If I just start with sand from the beach a few blocks away and mix it in. So, I have no idea what I want or where I'm going. I just keep growing and learning.
Yeah, thanks so much again for joining us, Lisa.
Yeah.
There's, everybody's kind of looking to commit a different amount of time and energy to this, and that's totally fine. Both of us, at some point of our career, we were like at this point where it was just like wild clay light. Like we could only commit so much, time and energy into the practice. And then eventually, it just kind of became a little bit more holistic and just trying to focus on doing as much as possible, just about everything with local materials. But we'll try and, share some techniques and ideas that can help people at different stages of that. Yeah. So if you don't want to, fully commit to the labor and time, there's still, plenty of ways to sort of bring nature into your work, like the sand, as you mentioned.
Yeah. And if you are interested in things like mason stains, we don't use mason stains a lot in our studio, but some of the techniques that we're going to share later today about doing a line blend we're going to be doing 2 different local clays, but the same technique will apply if you want to try to figure out a color gradient using mason stains. So the technique, even though we're demonstrating it for local materials, it's relevant to different applications too. Mm-hmm. So, okay. Dorit, I'm sorry if I'm mispronouncing your name.
It's okay, it's Dorit. I'm from Denmark, a small country in Europe, and we nearly only got earthenware and not a lot of mountains, and so it's a very flat country. I've been working with clay for 25 years, but for the last 5 years on full time, and graduated this week from art school with ceramics as my main subject. And I've been for the last 2 years, I've been working with local clay and ashes and sand and stones, different stones. And for my graduating project, I was working with local materials, and I collect materials in places that I have a connection to, or places that I just think is interesting, and and I like to to share the knowledge with you and all the others.
Yeah, thank you.
Thank you so much. Congratulations on recently graduating. And
Thank you.
I have to say, we were admiring the wall of samples behind you. That's beautiful to see them all together like that.
Yeah, that's some of them are with the local materials.
Mm-hmm.
All of them.
Nice.
Wonderful. Yeah, we are excited to learn more about your work and your materials and everything.
Mm-hmm. And I just admire you. It's so inspiring.
Oh,
thanks.
Thanks so much.
But my English is not so good because it's seldom that I speak English.
Yeah. Well, we'll provide all the recordings later. So if you need a refresh.
Yeah.
But I can understand, but my spoken English is not so good.
Well, thanks again for coming. Linda Lopez. Oh, she might not be logged in.
Yeah, we might come back.
Okay, we'll come back. Beverly Somerville.
Hello. I'm Bev and I'm sitting here in the UK, in Cheshire. I've been potting for lots and lots of years, but I've only been kind of have my own workshop and trying to develop my own practice maybe for the past 3 years-ish, maybe. I also work for IKEA as a freelancer. So what I've been doing is, as I live this nomadic life, traveling around the world, I take materials and, I don't know, things that in certain places that have meaning, that I relate to, that inspire me. And then I've been adding them into my porcelain clays, but not with any kind of understanding or, scientific kind of, just been creating with them, really, putting them in the kiln and seeing what they do, how they respond, making pieces that I respond to the place, whether I carve into it or some slab building, though I mostly throw. So I'm really looking forward to kind of, having a deeper understanding of what I'm doing rather than just throwing it in the kiln and hoping for the best. Some disasters, there goes another kiln shelf, but there's some really exciting things happening, but I want to kind of develop that and understand what the materials are doing rather than it just being a look at the drawer kind of thing. So I'm very, very excited.
Yeah, thanks so much for coming. We have a few techniques for keeping things very systematic, I guess you could say, in the testing process. But we'll also encourage, I guess I should say, we hope that this workshop gives people the confidence to just test things in the studio themselves without always following a really rigid, systematic approach. Because Mitch and I, we do test things rigorously, but sometimes tests will start off just very simple, just exactly like you said, just popping something into
what does it do
and seeing what happens. So, we have systems, but we don't always use them, and it's okay if you don't do that. If you don't always have a system. So,
no rules, only guidelines.
Yes,
that's something I like to say.
Yeah. Well, thanks again, Bev. Louise Smith.
Hi, I'm Lou. I'm from a little seaside town called Margate in the UK as well. My work has kind of always been inspired by the landscape that I'm in, kind of natural forms and meeting architecture and man-made things. But I'd really like to kind of make a deeper connection between the kind of, what the subject matter is and the actual material that I'm using. And I guess I haven't really known where to start. So I've always been really inspired by people that use that just go out and kind of dig clay, but it's quite overwhelming, those kind of the different processes and things. So yeah, that's why I've joined today. And yeah, also maybe similar to the printmaker as well, I do a lot of like drawing and collage and things as well, so I'd like to make pigments as well to use in my work. So yeah, I'm excited to join today.
Awesome. Thanks, Lou.
Yeah, so I guess in response to the pigments, I said earlier that we've never had another printmaker or someone working with pigments in our workshops that we know of, but we do have something that Mitch will demonstrate a little later tomorrow, I think, where we've created our own crayon using a clay, and we use it kind of as an underglaze pencil. So we'll show that technique tomorrow, but it's, you know, it would work on as like a chalk pastel as well. So it's kind of fun. Kara Bunn.
Hi, I'm Kara. I'm from Hamilton, Ontario in Canada. I started out as a printmaker, then switched to landscape architecture. So I find it interesting that I've got a lot in common with the people here. And then 10 years ago, I started managing the parks and cemeteries for the city I live in. And I felt a real loss of connection to art with that, because it's a lot more maintenance and very stressful, and I was needing something else. And so I started doing pottery, and I realized that I was able to sleep at night again when I was doing pottery, because it calmed me down and just turned off my brain a little bit from work. And so when the pandemic hit, it was awful for me, because the studios I was working out of, they shut down. And a lot of the stores, and it was hard to get clay. So I started digging my own clay and pit firing it, because I didn't have that. So, you know, I'm really interested in taking it further and looking at what I can do with a kiln, and what how I can use them as glazes and things like that. Because right now it's just very basic that I've done. And my city's made up of amalgamated little towns. And so I've been going out to all the different locations to try and get clay from each of those different towns. And I'd like to be able to, you know, as a city, show the variety of different clays and stuff that we have here. So
that's fantastic. I love that idea.
Beautiful, yeah. Yeah, and it sounds like with landscape architecture and the the planning job that you have, do you get access to local materials as you're out in the field? I don't know if that works.
Yeah, my staff, I have 400 staff that are always looking for clay for me. And I'm like, here's a bucket, fill it up, and they'll bring it back. Yeah,
that's the way to do it. Yeah, you don't have to do any digging yourself.
That's great.
That's awesome. I love it. Okay, who's next? Nancy Kwan. Nancy Kwan, are you here?
Maybe we'll loop back at the end.
Yeah, I think Nancy, we can hear a little tiny bit of sound, but I'm having a hard time picking you up on here. So we might come back to you in a few minutes. But Nancy Fuller, did you want to introduce yourself next?
Hi, can you hear me? Oh, is that Nancy Kwan now? No.
It might be.
Can you hear me okay? Yeah.
Yes.
Yeah. Hi, so I'm in Scotland. I'm living in Perthshire, and I have an anagama kiln up in Aberdeenshire. I did a training in 2006 with an anagama master in Shigaraki, and so I was introduced to raw materials then. But since getting back to the UK, I'm having to source my materials mostly from England, because it's hard to get stoneware materials up in Scotland. So in the new year, when I saw your course, I was really interested, because if I want to use raw materials more, I probably have to drop my firing temperature. That is one thing. And I'm really primitive in my approach, to sort of like caveman style. So I would like to inject some discipline in and do yeah, get more sort of results I can analyze. And then the other thing has been, during lockdown, it's been really difficult just having a wood, relying on a wood kiln for firing. So I'm looking at, how I might be able to get sort of results which would go with my wood-fired work, in an oxidation firings. So that's why this is so attractive to me. So, but yeah, I'm just keen to pick up any tips I can from you guys.
Well, we're so thrilled to have you join us, Nancy.
Yes. That's interesting what you were saying about not being able to wood fire so much during lockdown. Is that because you couldn't have a crew come out to help you fire?
Yeah, because of the travel ban and then social distancing, where we stay and, and all this kind of thing. Just the logistics were just impossible. So yeah. So yeah, I just from resilience, I just realized that I do need to sort of be able to incorporate something else into my practice for difficult times, or when I don't have the physicality to do it all by myself, kind of thing.
Yeah.
Yeah.
We so it's interesting you say that, because when we moved to Minnesota from California, we were basically moving away from like a guaranteed wood kiln. Because in California, we were doing a wood firing residency. So there was a kiln on the property where we could fire basically anytime we wanted to, as long as it wasn't fire season. So moving here had really forced us to change our approach and to try and make electric firings more interesting. Or interesting to us, at least. So yeah,
that's been a big part of the challenge, just because wood firing, as you know, and as anybody else who's done wood firing knows, is the labor and the investment is just incredible. So yeah, it's nice to have something that's just a little easier on the body, but still fulfills that that sense of wonder and amazement with materials.
And it's not really simple or really straightforward to make something that's sort of comparable, or so yeah, so I've thought about it for a long time. So it was really great when your course popped up, so.
Thanks, Nancy, for joining
thanks
us.
Again.
Evelyn Lamb.
Hello.
Hi.
My name's Evelyn. So I'm located in Toronto, Ontario. So quite a few of us. I started working with clay about 3 years ago as part of my degree in architecture. So there's a couple of us here. And my research was focused on brickyards in the city of Toronto. So one thing that I did was going to the sites, seeing what they were, whether they were parks or like TTC stations, and trying to go in and document how the site changed over time. One thing that I didn't do during, because I wanted to graduate, was to harvest local clay and make work from it. But I figured now was as good a time as any to get into it and see if I can revisit that kind of work later on.
Yeah, using clays from old brickyards, that's something that we've started getting into since we moved here in Minnesota. There used to be brick manufacturers in the state a long time ago, but they've all since closed down. But using some old industry publications, we kind of figured out where they were and were able to get some of their old stockpile of clay.
Yeah.
So
yeah, we're excited to maybe hear a little bit more about your experience with the brickyards in Toronto.
Yeah. Britt Johnson.
Hi, everyone.
Hi.
I would say my experience with natural clays actually started like 30 years ago. That's what got me interested in clay to begin with. I was a little kid, like 6 years old, with my mom, and we'd go out during the day just with my brothers and play in the rivers. And one day we found like all this clay in the river, and my mom, being the awesome creative lady she was, let us bring it home. So I remember this like couple weeks in the middle of the summer where we just sat on the kitchen table with this pile of clay, when, you know, I was this little kid, and we just created and created and created with it. And I just became obsessed as a little kid. And my mom started getting me in classes when I was little. So I've been off and on working in clay like my entire life. Started throwing when I was around 11. But I don't know, I think people scared me off from thinking I could make it a job for a long time. So I actually like, went into film professionally because for some reason I thought, you know, that would be a great idea. Couldn't stand the hours or the people, to be frank. So I came back to clay professionally almost 3 years ago. So same with a lot of people here. And it's been just an absolute whirlwind for me. Things have been great. But I found that I'm really like a total sentimentalist, and I'm really kind of missing some meaning in my work. And I think I just keep going back to those feelings of like, you know, pulling that clay up as a kid. And I'm in Portland right now, Portland, Oregon. And so the ultimate goal is to hopefully get back to Texas, where I grew up as a kid and some of my family is, and find some land to, you know, kind of live on. And I keep joking about this clay ranch to like, you know, dig up my own clay and build a different studio there and so forth, and really kind of put that sentimentality and meaning in my work, because I really like where I'm headed with some of my work. I do some light glazing, but kind of to highlight the raw clays that I work with right now. But I really just want to, you know, put something a little more meaningful in there, and, you know, find a sense of place in my work. Yeah, so really excited to take the workshop and learn. I've emailed you guys. I've dug up some clays here to, I'll go hiking a lot in Oregon and just sort of like accidentally find clays and fill my pockets as I'm going. I'm not planning on it, but I've learned to sort of hike with, you know, Ziploc bags at this point, because I'm just like this natural forager. So I have, you know, just these weird bags of clay right now, and I kind of don't know what to do with it, because I do fire at a community kiln too, which is a problem. So I, you know, work closely with them there. So they're open to me working on it, but they kind of want to know that I know what I'm doing. So yeah, this will be a great help.
That's awesome. I love that story of you and your mom digging up clay and her just like letting you go to town with it. I think that's wonderful. And
yeah, early experiences.
Yes. But I have to say, you're not alone, like hoarding clay when you're on hikes. I can't tell you how many times I've done laundry and found just like rocks and other random things in Mitch's pockets.
Oh, I'm terrible.
So it happens a lot.
Yeah.
Maybe that'll make my husband feel a little better. So
yeah. Clay Hoarders Anonymous.
Yeah. Okay. Thanks again for introducing yourself. Janaka? I'm sorry, Janaki?
Hi, it's Janaki.
Janaki, thank you.
I was just cracking up because I was just with my daughter the other day, in which she's 11, and I was walking down an alley and there was a construction site with a bunch of clay. So I was picking it up and she was like, I am not getting in the car with you with that clay. There's clay all over the dashboard of my car. There's like sticks and rocks everywhere. And so, yeah, we should all start a group together for sure. I'm located in Vancouver, Canada. I've been working with clay for 22 years. My mom was also a potter, so it's been in my life since I was born. I'm primarily a functional production potter, but I've always been interested in like the minimal amount of processing possible. And then in the last few years, I've started to, again, Vancouver's famous for its construction. So there's just clay everywhere. So I got talking to some people and I was like, well, what do you do with it? And they're like, we pay to get to dump it. So I've started collecting, you know, buckets from different sites and then trying to process it. But my issue is that I have no problem blowing things up and just winging it. It's the technical side and understanding just how to actually come up with a system and sometimes follow it if I want to. So that's what I'm hoping to learn. I'm really excited about triaxial blends. Is thrilling to me. So
that's awesome that you think triaxials are thrilling. I think it's a lot of math.
I like hearing that.
But
I'm on the same page.
They're so beautiful though. And we'll actually do triaxials tomorrow and when we do them tomorrow, we'll be talking about them in relationship to, or in regards to how to make a glaze, but you can use the same technique for mixing 3 different clay materials too. So
yeah, so if you wanted to make a clay body or just a slip, you know, it all applies.
Yeah.
Yeah, no, it's amazing. And I've got so many ash like samples from different things, like just so many samples that I'm stuck on only understanding how to use them in one certain way. So very excited to broaden that.
Yeah, absolutely.
Yeah. So thank
Exciting.
you.
Yeah, thank you.
Thanks.
Okay, Reet. Actually, I'm not sure if they're logged in. No, not logged in. Okay. Perry Lee Pipkin.
Hi, I'm Perry Lee. I am currently temporarily in Portland, Oregon, but that's not where I'm from. I work as a field botanist around the Western US. So I travel a lot. I've been based out of the Southwest a lot and was just in Nevada and Wyoming, but I end up spending most of my day hiking around and finding clay everywhere and packing clay out of places. I've been working with clay probably since I was a teenager. My dad's a potter, and so I was kind of always around it. And I think maybe like 5 or 6 years ago, I had a teacher who worked primarily with wild clays. And so when I was out in the southwestern deserts, I started digging a lot of clays and kind of working with it, and mostly just doing pit firings and that kind of stuff. And then recently met some really cool people that taught me about making earth pigments and pastels and all kinds of things, and that like really like changed the way I saw everything, and started seeing more, or like getting really excited about just the colors everywhere. And so I haven't been experimenting a whole lot, but I have a studio filled with bags and bags of clay and rocks and colors and sands from all over the Western US. And yeah, I was just like slowly making my way through it and processing it and just seeing what happens. And I have no idea what I'm doing. I'm just sort of like, this is cool looking, and then put it in the kiln, and sometimes it melts, and sometimes it does. I'm just kind of messing around with it. But yeah, so that's I'm just excited to see how everyone else works with materials and maybe get a little more direction about where to take it. And yeah.
Excellent.
That's wonderful. That sounds like a dream job, being a field botanist and just getting to hike and be outside all day. And actually, in addition to all your rock and clay collections, tomorrow we'll also be covering how to use certain plant materials in glaze applications. So you can even combine your 2 interests that way, I suppose. But, okay, I think that's everyone who's currently here who is on our list. Nancy Kwan, do you want to try again to introduce yourself?
Hi, I feel like my audio has some issues. Can you hear me?
Yeah, now it's good. Thank you.
Hi, I'm Nancy. I live in LA. I'm a ceramic artist, and yeah, I wanted to take this workshop just to have, just this desire to better understand my material and see how that informs the work I make. Yeah, pretty much it.
Awesome.
Nice.
Thanks so much for joining us, Nancy.
Yeah. Anyone else who is here who would like to introduce themselves?
Hi, I joined a little late. I didn't get to introduce myself, but I'm Sama. I'm an architect. I'm based in Brooklyn, New York, and I've been doing ceramics for a while. I'm originally from Amman, Jordan, in the Middle East, and I was able to spend a little extra time there during the pandemic. And I have a studio in New York, a studio space for ceramics. And when I went home, I was looking for some clay to work with and noticed that most of it was imported from abroad. despite the fact that the resources are available in Jordan. And so I've started collecting clays and other materials, and I'm looking for ways to test them and to kind of learn more about that process and what I can do with the materials that I found.
Yeah,
That's wonderful.
thanks so much for joining us, Selma. Yeah, are you talking about clays in Jordan that where they mostly import from other countries, but you know?
Yeah, they import processed, like the clay that's ready to use, clay bodies that are ready to use, and no one really uses the local resources.
Yeah, it'd be so exciting to dive into that.
Yeah.
Would love to hear more about what you've sort of discovered so far. Yeah.
Yeah. I'm excited to share all of that and learn more about the work that you do.
Thanks so much. Is there anyone else here who wanted to introduce themselves?
Hello, I'm David De Silva. So I'm working out of like a few miles outside of Washington, D.C. In Brentwood, Maryland. And so I've mainly been working kind of like making functional wear at a studio. We're doing kind of like a restaurant commission right now. And so we're kind of working in, more functional wear. I've done, previously done sculpture and stuff, but I've always been interested in trying to work more with local materials, just from kind of more of a kind of, I guess, like ethical place. And so we do work with Starworks clay right now out of North Carolina. But I do like the idea of potentially, testing and foraging and stuff like that. I did do some work in school. So I took some glaze chemistry and clay formulation. And so I feel like I haven't really, not sure how I would connect that to the foraging. And it seems like, I really have done very little foraging of clays or anything like that. So I just thought this would be kind of a good way to get myself into it, because I've been telling myself I will for the last 4 years and I haven't done it. So yeah, I'm excited to kind of learn about all of that.
That's awesome.
Yeah, absolutely. You said you're working just outside of Washington, D.C., was that right?
Yeah, in Brentwood, Maryland.
Okay, so there is a really amazing resource for clay. I'm not exactly sure where in Maryland it is, but it's called the Stancil's Clay Mine. And there are a lot of artists in the Mid-Atlantic who collect clays there. And some of the materials that they have available at that site are just fantastic. So I will try to find some resources and we'll send them your way, because and we'll also send some links to other artists who, frequent that place.
Yeah. So I grew up in the Richmond, Virginia area, and I did a ceramics residency out in Appomattox. So did Mitch back in the day. But that ceramic residency in Appomattox was kind of where we both got started using local materials. And the clay resources in the Carolinas, Virginia, and Maryland area are just fantastic.
Yeah.
And I love that you are using clay from Starworks. For anyone in the US who isn't familiar with Starworks, they are basically like a mom and pop clay manufacturer, but they use only materials local to their location. And they do ship, I think, up to 50 pounds of clay throughout the US. So it's kind of a nice way to use hand processed and hand foraged material, but without actually having to go do it yourself. So.
Yeah, so it's still processed, but it has a much lower carbon footprint than, getting a clay body where one material comes from Australia, the other comes from Canada, the other comes from, Kentucky.
Yeah.
Yeah.
A little bit more local. And everything's already tested for you too, so it'll fire safely. Okay. Anyone else who wants to introduce?
Great.
Okay.
Well, it is so exciting to kind of hear what everybody's up to. Everybody's sort of responding to their own materials in their own locations in really interesting ways. So that's really, really great to hear. I think just to kind of move on to the next section, we're just going to quickly go over the overview of today, and then after that we'll kind of pop into a little bit of a presentation. But the first thing we're going to do is just go over this presentation, just share a little bit more information about what is clay, what are the different types of clay, how do they form in the environment, and how can you, regardless of where you are, find that material using different resources. So there's kind of a lot of information packed in there, but it's kind of a good starting point, because I think a lot of the questions that people ask, we really try to kind of sum up in that presentation.
Mm-hmm.
And then, sorry.
Well, so that presentation will take about an hour. So after that, we'll have a little break for questions, and then we'll take a 5 to 10 minute break, depending on how we're doing with time. And then,
Yeah, so then after we talk about, what is clay, how do we find it? We would ideally like to, be working with the clay together, but, because of this situation, obviously that won't be possible. So what we're going to do is just kind of take you sort of on a tour with us, and we're going to bring out some raw clay samples that we've collected. And we're just going to go over our kind of initial responses to the material as if we were discovering it, together in the field for the first time. So we'll just kind of go over, its properties and how it works, and, how we think it might behave in a kiln. And then from there, we will talk about how to prepare the initial tests. So actually seeing how it responds to the temperature in the kiln. We'll kind of interpret those tests after they've been fired. And then that will kind of be our transition into the processing section of the workshop. And we'll just walk you through our particular method for, preparing the clay. So like screening it, drying it. And then at that point, we will talk about more about kind of blending methods, and specifically talking about how we in our studio like to approach blending different materials to create clay bodies. And so a lot of that involves just looking at the results of the initial tests. What does this clay do? What does this clay do? And then, what happens when we combine those? Because that's where you're really able to sort of customize things, but also, really develop and open up the doors to some more unique qualities that you can achieve in your studio, regardless of whatever materials you have access to.
Yeah. So at the end of that, we'll kind of have plenty of time for questions, and then wrap up today's session. But today's session is really going to be focused on clays and clay bodies. And then tomorrow we'll be going over more about slips, how to produce slips, slip glazes, and then what we call triaxial glazes. So tomorrow is a little bit more about surface decoration. We'll also be doing anything with grogs and stones and sands tomorrow. So yeah.
And then at the end of the day tomorrow, we have some time set aside where we'd like to invite everybody to share anything that they are working on or have discovered or have questions about. So that's always, one of our most, favorite parts of the workshop, is seeing what you all do.
Yeah. Yeah. So I guess before we begin, just some really quick etiquette things. We ask that throughout the workshop, you keep your mic muted unless you're asking a question. That just helps with the recording. And yeah, it'll be easier for everyone to understand. We do welcome questions in the chat at any time. You can always put a question in there, and we'll either answer it as we're working, or we'll come back to it when we stop for a Q&A session. If your question is relevant to what we're currently doing, you can also ask it live by unmuting yourself. We really like that because it makes people feel like they're more in a classroom setting, and it's not just us talking at you all the time. But if you feel more comfortable using the chat too, that's absolutely fine. We ask that during the PowerPoint presentation that we're going to give in a few minutes here, you just hold your questions until the end. And once again, you can always put questions in the chat, but we'll get to them at the end just because we have a rhythm for the PowerPoint. Yeah, and then Mitch went over the schedule. And in case this wasn't already obvious, we're asking people to watch alongside us as we teach today, and then practice the techniques on your own after the workshop, just because we've done quite a bit of preparation ahead of time. I apologize, we have really noisy neighbors and we didn't think they would be here today, but they're unfortunately like making the floorboards creak above us.
Yeah, hopefully it won't get too bad. But...
Yeah. Okay.
Yeah.
Any questions before we begin the PowerPoint? Okay, I'm going to go ahead and share my screen then. Okay, sorry about that. I just updated my computer a few days ago, so it reset my settings apparently. Okay, so now we're going to be sharing my desktop. Just move that out of the way. Okay, can you guys see that? Go ahead and give me a thumbs up. Yes. Okay, awesome.
All right, great.
Good.
Pull up the notes on that. So we just want to begin by saying that we collect materials from all over the state of Minnesota. And although we obtain permission from the landowners before prospecting or digging, we still recognize that we are working on stolen land. So we would like to take this moment to acknowledge the Dakota and the Anishinaabe people who are the rightful owners and the original stewards of the land that we are working on and the land that we collect materials from.
Yeah. So we're all here today because we're interested in the places around us and the resources found within them. And we believe it's important for everyone to remember the relationship that Indigenous cultures have had with the same land for hundreds to thousands of years before us.
So during this workshop, we're going to be talking a lot about how to find materials and how to use them. But before we do that, we thought it would be nice to actually define clay from a few different perspectives. So beyond ceramic art, clay is used in many different industries, ranging from paint, paper, rubber. It's in the auto industry, aerospace, cement. Really just about every industry you can think of is using some type of clay. So we as artists might be looking at clay for its, its workability, but other industries might look at the clay for its ability to, produce something that's very resistant to heat, or, contributes a very white color, or contributes sort of like a gelling property. So something that can turn a liquid into a gel. Because there are many different industries that are using clay, defining them can be somewhat complicated just because sometimes people are using a lot of different languages to sort of talk about this. So we are going to be looking at clay as a mineral, so sort of looking at its chemical identity. We'll be talking about clay deposits, so looking at it from more of a geological perspective, how these minerals exist in nature and move throughout nature. And then we're also going to talk about them as in relation to clay bodies. So how are these materials used in ceramic art? All clay is a plate-like mineral that is weathered rock, specifically coming from a group of rocks called aluminosilicate rocks. So these are consisting of the elements aluminum, silicon, and oxygen. different types of these rocks can become altered and weathered to different types of clays. So some of the variations of clay's properties include plasticity, which I'm sure everybody here is familiar with. Clay minerals are unique in that their shape and their sort of chemistry allows them to stack and slide when wet, and this is what gives clay its characteristic workability. Clay also has what's called a tensile strength, and so this is the ability to withstand a certain amount of pressure before breaking. Some clays are very fragile when fired, and others are very durable. But in general, all clay is going to have a higher tensile strength than like a block of dirt or a block of sand, just because the particles are so fine, it can withstand more pressure. When clays are heated, they eventually reach a point where their particles sinter together and fuse. This is at about 1,650 Fahrenheit or 900 degrees Celsius. And at this point, the clay cannot be returned to a workable state by adding water to it. So this is what we call the bisque fire temperature. So it's the temperature that you might fire something to if you're going to apply a glaze to it. Beyond this temperature, each clay reaches a point at which it vitrifies and kind of becomes glassy. And this temperature really depends on each clay's chemistry. Some clays, are made up of elements that are very refractory and can withstand high temperatures. So like porcelain or stoneware or fire clay, those are what we would call refractory clays. And those are opposite from fluxing clays. And these are clay deposits that have a higher mineral impurity, things like iron, calcium, magnesium. These all lower the melting temperature. And so these are called fluxes. Despite having similar properties, clays may actually look very different under a microscope. So these are just some of the common clay minerals. Kaolinite is probably the most familiar to us. This comes mostly from potassium feldspar, mostly coming from granite or granite type rocks. Illite is another mineral which comes from mica-rich rocks. An example of this would be muscovite, which is kind of like a really thin, flaky, very soft rock. Chlorite comes from iron and magnesium-rich rocks. So these are generally darker in color. Good example of this is biotite, which is one of the main components in granite, as well as other rocks. And then the last group of clay minerals is a little different. This is called the smectite group. In a lot of old geological documents, they used to refer to it as montmorillonite. But this is essentially just volcanic ash that has weathered to clay under very specific conditions. And these clays are unique in that they actually swell and absorb water. So if anybody's used bentonite to kind of keep a glaze from settling out, you're using this type of clay mineral, smectite.
So to simplify things for this workshop, we're going to be focusing on defining clays from more of a geological perspective. In many other fields, the specific chemistry of the clay mineral is very important, but for us as artists, it's just not as relevant. So as a natural material that changes over time, clay is connected to a physical place, and we prefer to examine it through that viewpoint. In this way, we can easily break things down into two main categories, primary and secondary clay deposits. Primary clays are clays that have been chemically weathered from feldspar and into kaolinite. And an example of a primary clay is kaolin. Secondary clays are just primary clays that have been transported away from the original source. And during that transportation process, they've been mixed with other organic matter and other minerals along the way. So some examples of common secondary clays are ball clays or earthenwares. it's important to distinguish clay minerals and clay deposits from clay bodies, which are customized blends of different materials for a specific purpose. So these kinds of clay body blends are made from blending different clays as well as non-plastic materials like silica, fluxes, or sands and grogs. So on the screen here, you can see some common examples of manufactured clay bodies are stoneware, porcelain, terracotta. Really, they go by many different names, but a clay body is just a recipe of different different clay deposits, really.
Yes, just going back to that for one quick second. So an example of porcelain, just a very generalized porcelain recipe would be 4 ingredients, each used in like roughly equal parts. So one part is kaolin, and that contributes sort of the white brightness and the refractory quality to it. The second component is usually a ball clay, which actually gives the porcelain a little bit of workability. And then the third and fourth components are in the non-clay category. So a lot of silica is what gives porcelain that glossiness. But then that silica and the refractory clay, they have to be fluxed down. So feldspar is commonly used to sort of, lower that melting temperature. So that's just kind of one example of how all of these materials come together into a clay body.
Yeah, it's really kind of finding a balance between all the materials. So a good way to think about how all these things relate is to make an analogy to the human body. So clay minerals act as the building blocks. So in that way, they're similar to cells. Clay deposits are made up of one or more different kinds of clay minerals. And in that way, they're similar to how an organ or an organ system is made up of many different kinds of cells. And a clay body is kind of like being composed of many different clay deposits. Or if you were referring to the human body, it's like the whole organism. So I know that's kind of a convoluted analogy, but.
Yeah, so we'll just talk about primary clay here. Primary clay, as Zoe mentioned, it forms as feldspar in various rocks, weathers into kaolinite. And this weathering process is called hydrolysis. So this is hydro, which is water, lysis, which is breaking. So this is just chemical weathering of the feldspar into kaolinite. So as a generalization, high feldspar rocks, so rocks that have a high concentration of the mineral feldspar, have a greater potential of becoming clay compared to low feldspar rocks. In addition to the rock itself and its chemistry, the process also requires warm, to hot temperatures and a high level of moisture and humidity over a span of millions of years. So this is not something that occurs everywhere on Earth. In general, it normally occurs closer to the equator, where there's a lot more moisture and the temperatures are consistently hotter. And it's also not something that we can produce on our time scale. So just to put this in perspective, much of the world's primary clay deposits began weathering during the Cretaceous period. So this is about 145 to 65 million years ago. So at this time, global temperatures were significantly warmer, which resulted in the ice caps melting, which results in higher sea levels. And so you have warm temperatures and a lot more moisture kind of sitting on top of these rocks and sort of holding those atmospheric conditions for this period of millions of years is what has resulted in the primary clays that are being mined now. So the source of most primary clays is granitic rocks. Sometimes we use the word granite Sometimes I say granitic rocks, just because there's really a wide spectrum of granitic rocks, granite just being one of them. But just in general, granite usually consists of three main minerals. There's quartz, which is essentially just silica, feldspar, which consists of some silica and alumina, but also a higher percentage of one of four different fluxes, either potassium, calcium, lithium, or sodium. And these fluxes are what make feldspar, good for lowering the melting temperature. And then the third main component is some kind of an iron-bearing mineral. And most of the time in granite, this is some form of mica, which is, that kind of flaky, very thin mineral. In some cases, it's biotite, which is a black mica, which you can kind of see on the right here. So this has a little bit more iron. And then another option is muscovite on the left. And so muscovite is usually a little bit more brown or gold. And so the ratio of these three minerals determines the type of granite, but it also kind of determines its appearance. So this granite on the left is pink because it happens to have a feldspar that's high in potassium. And that potassium, creates these giant pink crystals. It has some very fine-grained specks of this kind of white to clear mineral, which is the quartz. And then the darker grains are this biotite mica. I'm sorry, the muscovite mica. This on the right is also a pretty common granite, kind of like a salt and pepper appearance, but it has these white minerals of calcium feldspar. So usually calcium feldspars are kind of white to, just slightly pink. And then the darker gray minerals, these are again that quartz. And then of course you can see the black, flakes of that biotite mica. So when this primary clay becomes weathered, they often retain the same structure as the original rock because the particles haven't really had the chance to, sort of be eroded and transported and broken down in size. And so here you can see the feldspar has been weathered into kaolinite. And so you can kind of see these sort of, milky, clear bands of this kaolin. The quartz actually remains unweathered. Silica takes a lot longer to break down in the environment. It's not as, susceptible to weathering through this process of hydrolysis. And so in this particular deposit, you have these layers of this sort of quartz sand, this sort of lavender sand. And then the mica, that third component, mica very easily weathers into clay minerals and then just becomes washed away. Sometimes it will become so thoroughly washed away that, the resulting deposit is just white. Sometimes it will be stained, like a subtle orange or a subtle red.
Yeah. So although pure primary clay, kaolin deposits are somewhat rare, they can be quite remarkable when found in the landscape. So this image on the left here is an example of a pure, really stark white primary kaolin. Kaolin and other primary clays are often lighter in color, but other minerals in the surrounding soil or rocks can stain the clay over time. So minerals like iron, copper, and chromium can all stain that really white clay until you see something kind of like the image on the right here. Because primary clay deposits are so old, they are often buried deep beneath more recent sediments. So you might have to dig or find an open exposure if you want to use one of these kinds of clays. Primary clay deposits are also referred to as saprolite, and the word saprolite comes from the Greek word for rotten rock. Saprolite is really just a large area where the rock has entirely weathered, leaving little trace of the original parent rock behind. And some common properties of primary clays are that it's very coarse. It can be difficult to work with on its own because there's a lot of rock debris from the unweathered quartz mixed into the clay. So it tends to be very crumbly and sandy. There's also a relative lack of movement in the environment that would otherwise break down the particle size. So it just hasn't had enough time to really become a smooth clay. Primary clays also tend to be very refractory, as the granitic rocks that they come from are high in silica and alumina, which are both very refractory materials. And granitic rocks also tend to be a little bit lower in iron, which is a fluxing material. So any clay that's derived from those granitic rocks will share those same properties. Primary clays are also found typically near the parent rock. So the deeper you dig in a primary clay deposit, the more of the parent rock you'll encounter. Primary clays that are transported away from their original source are deposited again later on as secondary clays. The transportation process may separate out the minerals by particle size, making them more plastic. So in this example here, some of this clay might move away from this original source in that stream. And as the clay is moving in the stream, the larger particles will naturally fall to the bottom of the stream and the smaller particles will travel further, meaning that those small particles, when they eventually become deposited, will lead to a more waxy or fine-grained clay.
So there are many different ways that clays and sediments are transported, and how they are moved and where they are eventually deposited really affects their properties and their appearance. So these are the main methods of transportation, and these words kind of pop up a lot in geological documents, so they can be really useful. But the first is lacustrine, and so these are sediments that are deposited in ancient lakes and seas. So as streams and rivers carry sediments away and deposit them, in lakes, they just eventually accumulate along the base of the body of water. Fluvial deposits occur as sediments are deposited along riverbanks, so like physically alongside, the trajectory of the river. This is related to, but different from, alluvial, which are sediments that are deposited by rivers, but they are dumped in floodplains. So a lot of the time you see this at the base of mountains or steep hills where, rivers and streams sort of carry these sediments down the mountainsides, and then they sort of dump them in areas where it's just flat. And so this often forms what's called an alluvial fan. And it's just a stream of sediments that kind of fans out. And if you look at it from an aerial view, it kind of looks like tree roots, which is really beautiful. Glaciers can also, be very powerful tools for sort of shaping landscapes and moving clays. Glaciers can form clay deposits both by physically plowing the sediments as the glaciers move, mixing them with different sand and boulders along the way. But they are also, closely related to these first three, more water-based methods, because as the glaciers melt, the streams and the lakes, those are going to be closely related to the glacier. So in a lot of documents, you'll see these sort of spoken about in relation to one another. But the last one, which is really fascinating, is called an aeolian deposit. And these are just sediments of clays and sort of fine-grained minerals that are deposited by wind. And this type of clay is specifically called loess, which is just a really beautiful word. But these types of deposits normally occur in deserts in more arid climates where there's not enough plant life to form roots that really hold the sediments in place. Secondary clays are often contaminated by minerals and other organic matter in nature. Most of these contaminants like iron, calcium, sodium, and magnesium melt at lower temperatures, and thus they ultimately make the clay less refractory. So the more clays move through the landscape, the more of these contaminants they pick up, and ultimately the lower their melting temperatures become. So their workability and colors can vary greatly, and they can form in all of the types of environments that we previously discussed in the last slide.
So ball clay is a very common type of secondary clay. It's characterized as being a very fine-grained clay. It tends to be waxy sometimes. The color is often gray or sometimes black, blue, or green. And all of these colors can be attributed to the organic matter in the clay. Ball clays are often deposited in swamps, lakes, or other aquatic environments. And as the clay settles on the bottom of those bodies of water, they naturally become contaminated with a high carbon content. And the lack of oxygen in that environment will turn the color of the clay to one of those cooler toned colors. Yeah, it's similar to what you find at the bottom of an old slip bucket. You might have a slip bucket that you made using porcelain clay, but if you've just been letting it sit out for a long period of time, and then you go to clean out the bottom, you might notice that the bottom is black, and that's from the same kind of carbon coming out of the clay. Another type of secondary clay is earthenware, and we categorize earthenware clay as secondary clay that's been contaminated pretty heavily from other fluxes, which overall lower the firing temperature. So these fluxes could be things like iron, calcium, magnesium, really any other mineral that's going to affect the temperature of the clay. Most earthenware clays will melt around 2100 degrees Fahrenheit or 1150 degrees Celsius. And earthenware clays are often, but not always, darker in the raw state. And they tend to fire a wide range of colors. So they could be brick red, orange, brown, many different colors when they're fired. And firing color also depends on the firing atmosphere. So if you fire these in a pit firing, it's going to be different from an oxidation electric kiln. And then once again, different from a gas reduction kiln. But similar to the ball clays that we just discussed, earthenware clays can also contain a lot of organic matter, staining the raw clay, anywhere from black, green, blue to gray. So it's not always red.
So these secondary clays may eventually form a group of sedimentary rocks that are called clastic sedimentary rocks. So a clast being a fragment or a part of something else. So these are just, rocks made of smaller rocks. So clay particles are continuously washed away from the land, and then they end up being deposited in, oceans or large bodies of water. And over time, the accumulating layers condenses these sediments into sedimentary rocks, which eventually, become lifted up above the water level and exposed through different geological processes. So some of these rocks may be very dense and you have to really work hard to crush them, but others may be easily weathered back into clay in the landscape, like when you find them. And so these types of rocks can be really valuable resources for finding clay. Shale is a great example. Shale is recognizable by these sort of thin sheet-like layers, which can vary in thickness. Shale it just consists of layers of highly compressed clay. It's often extremely fine-grained and very free of sand. And so when you crush this into a clay, it's an extremely plastic, sometimes even waxy feeling clay. Siltstone is similar, except it contains slightly larger particle sizes. So silt is essentially just very fine-grained sand. Sometimes these two rocks are found in flat layers. This just kind of, on the left kind of indicates that these sediments accumulated, horizontally over time. However, they can also be found in these sort of uplifted and, churned and highly altered layers. So this on the right is an example of shale found on the Northern California coast, where tectonic activity has kind of, lifted and folded these rocks. Mudstone is very similar, except it contains other minerals and often different particle sizes. Unlike shale and siltstone, mudstone does not really break down into the same, thin sheets, but it can still be crushed or weathered into clay.
So it's important to note that very few clay deposits found in nature are actually 100% pure clay. When we purchase materials from a commercial supplier, those materials have likely been highly processed in order to achieve a consistent product that is almost entirely clay. So for example, if you go to your clay manufacturer and you purchase kaolin or China clay, you're only buying 10 to 20% of what is actually mined from the earth. The remaining 80 to 90% of what is taken out of the earth remains unused and is therefore entirely, or is very wasteful. We feel that the presence of organic matter, silt, and sand really gives natural clay deposits their interesting qualities. So it's helpful to think of clay in nature as being somewhere along the spectrum of pure clay, pure silt, and pure sand. So this soil triangle is a great way of depicting this. This type of diagram is commonly used for soil surveys and in agricultural settings, but it's also useful to us as clay artists. So the top right of this diagram indicates pure clay, the lower right, pure silt, and then the left-hand side, pure sand. In our studio, we use materials from all over this diagram, not just the top clay section. Having materials with different purposes or with different properties is very useful to us. And even if you only have access to a material that is 30% clay, and down here, for example, we think you can still find a use for it by testing it, figuring out its properties, and then later blending it with something else, which we'll demonstrate a little later on today. So I'm actually going to switch into a different document here to talk about this. Give me just 1 second. So we use different kinds of geological maps when we are first looking for clay before we even step out into the field. And the first type of map we like to use is what's called a bedrock map. I should mention that this map and the next map I'm going to show were published by the United States Geological Survey, or the USGS. You can find maps like this for just about any county in the United States by searching for them for free online. And similar maps also exist for other countries throughout the world. They're readily available on the internet. But this particular map is what's called a bedrock geology map. And here we're looking at just one county in the state of Minnesota. This is a PDF, so if I zoom in, you should be able to see kind of where the county is located within the state of Minnesota. So there it is highlighted there, that little triangle. You can see that this map is color coordinated. Each of these different colors is referenced down here in the key at the bottom. So for example, that peach color I was just highlighting looks like the formation is still unnamed, but it gives you a little bit of information about where that area is and what it's made of. Let's see. So I guess I should mention that a bedrock map indicates the parent rock in the area, which is not always accessible at the surface. However, these bedrock maps can still be useful because if you were to go to one of these areas looking for this material, you might be able to find a road cut or a riverbank or some other exposed strata that can allow you to still see the bedrock of that area. Yeah. So in order to read these maps, you can do them in one of two ways. You can either pick a spot on the map where you're going to be visiting for the day, find the colors that are in that area, and then figure out what's there by reading the map key down below. Or alternatively, you can read through basically all of this text to kind of figure out what's in which area and find probable places that could contain clay. So if you were to read through some of this map key at the bottom, you might want to be searching for certain keywords that relate to clay. Words like shale, siltstone, mudstone, or claystone, like Mitch just mentioned. Or you can search for words like kaolinite or saprolite. Sometimes granite can help lead to clay. But if we look at this very first color on the key, you see this nice like olive green color, and the lettering in there says KD. It stands for the Dakota Formation, which formed in the Upper Cretaceous period. And right there, those first three words, claystone, shale, and sandstone, that sounds like it could be a probable source for clay in that area if that bedrock has had the time to weather or if it's even accessible. So if you look for that kind of olive green color on the map up above, you can see there's quite a bit of it up in this area. So it might be worth your while to kind of take a little road trip to this section and just check it out. There's also some more of that olive green color down in the middle here. Anything you wanted to mention?
Yeah, and just for the context of this map, we should mention that this sort of bottom edge of this county, this really wavy edge, this is a very ancient river. And so the area kind of to the north and south of it is a river valley that's been highly exposed. So for the most part, all of this green, this claystone and claystone and shale kind of exists within this river valley. So once you kind of, become familiar with these maps, you can kind of get an understanding of, why certain things exist in certain places.
Yeah. So I'm going to cancel out of that map and show you one other kind of map that we use. So this map is from the same county, but you can see already it has a lot more detail. This is what's called a superficial geology map. So unlike the bedrock map, which shows just the parent rock or the bedrock down below the surface, a superficial geology map just shows you what's on the surface, maybe under a thin layer of topsoil, but whatever is on this map should be somewhat accessible. You can see it has a lot more detail than the bedrock map, and that indicates that there's been a lot more weathering and mixing of different materials. We also happen to have a lot of glacial activity, historic glacial activity in the state of Minnesota. So it causes a lot more surface disruption in our area. Hence all these small pockets of different colors. Just like the other map, this one is also color coordinated or color coded. The colors are different and stand for different things than in the last map, but you can still read this map in the same way as the other one. You can either pick a spot and figure out what's there, or be a little bit more coordinated and read through potential sources first and then find them. So
yeah, so the nice thing about these surficial maps is that they kind of tell you more about the recent geological events that have shaped the landscape, those being rivers, ancient lakes or floodplains. And these are all the different environments where clays are commonly found. So yeah, these surficial maps are going to be more useful for actually finding things than the bedrock maps.
And I do want to show one other thing. So I'm going to zoom out because reading through this is not super important for this class. But if you find a map like this on your own and you download it from the internet as a PDF, you can search the text in this map pretty easily. So if I go into the upper right-hand corner here in the search bar, I can just type in clay, and it should highlight every instance of the word clay down here. So there you go. You see clay many different times. That way you don't have to read through all of the text. Sometimes this text can be a little bit dense and can be difficult to read through. But searching for certain keywords like clay, siltstone, shale, all those words that we've been mentioning, those can really help you kind of narrow down your search from the get-go.
Yeah.
So, okay, let's go back to the PowerPoint. Okay. So the state and regional publications, like I just mentioned, can be found online, oftentimes for free. And these resources will usually outline clay resources that have been tested already for other various industries. So as I said earlier, these resources are also available for other countries online. It's not just the US. They can be a little bit dense to read through, but they're very informative. Oftentimes the research has already been done on different materials because of their use in other industries. So clays tend, not always, but often if these publications mention clay, they've already been tested for their firing range. And so you can kind of get a sense of what the melting temperature is for each clay. They also briefly talk about the properties of the clays. Some publications will even list the trace elements within the soil or within a material. And so that can help you determine if a material has heavy metals or other toxic contaminants. And therefore, if a material does have toxic contaminants, you might not want to use it in a food setting. The Roadside Geology book series, like is pictured on the right here, is a great resource. I think it's only available in the US, but I know they have one of these books for just about every state. They're great because they're easy to read and understand. They're all written in layman's terms, so much less dense than resources like this. They're also great because they're easy to physically navigate what they describe in these books. So they're all written as if you were taking a road trip with the author through the specific area that the book covers. And it even directs you to places where you can easily access the landscape to view it or just see it in person.
So there are also some other industries that are incredibly useful. I think a lot of folks here in the introductions kind of hit on these quite a bit. But obviously brick makers, any company that manufactures clay pipe, so sewer pipe or chimney pipes, historical potteries, any of these industries that use clay, historically they would have located themselves near clay sources. And so even if a company is no longer in operation, material may still be found in that area. They might even have stockpiles that you could, you could collect from if you get in touch with the right people. So if you ask your local historical society. Chances are they will have more information on, sort of historical industries that used clay. Granite and stone quarries often have to remove, a considerable amount of material in order to reach the stone beneath. And oftentimes this clay is of, little to no use to them. And so if you make the right connections, you could probably discover a fairly, extensive supply of clay from different quarries. And then, of course, excavators, construction companies, any industry that involves either leveling the ground or digging into the ground is quite likely to encounter clay. And most of the time, they're just, excited to give it away and, have somebody that can do something with it.
Mm-hmm.
So all of these resources can provide just a general idea of where to find clay, but when you actually are out in the field, we wanted to share some useful things to consider. It seems really obvious, but the first thing to remember is that fine particled materials are carried away by water. And so we always like to kind of look at the landscape and follow, the water to its lowest point. So the base of hills, valleys, the base of roads or ponds are likely to have much more of a pure clay than at higher elevations. So these are just two examples. On the left, you can see sediments kind of being washed down over this road in this extremely hilly area of southeastern Minnesota. And then on the right is just, this is just a hill at a clay pit, but you can kind of see the, at the base of this hill is this kind of blue-gray color where, there's just a higher concentration of fine clay particles. So these photos demonstrate this after, just like a single rain, but just consider the result of millions of years of erosion and how much material this can contribute. Road cuts, rivers, anything like this is going to expose the layers or the strata in the area. And these can really help you identify layers of materials and just kind of form a visual of how far down they are located. Dramatic colors in the, in these strata often indicate changes in, some kind of, sedimentary rock record. So on the left here, you can kind of see it goes from this gray to kind of like a brown yellow to a very thin layer with a lot of, sort of boulders and pebbles. And then on top of that is that sort of gray brown soil. And so this kind of indicates, multiple things that happened geologically. And the same goes for the photo on the right. You have these sort of stark contrasts between this blue-green layer, which is clay, and then this sort of sandy orange soil on top of it. So in both of these photos, this top layer is, it's glacial soil. So both of these deposits are sort of covered up by quite a thick layer of this soil. So it's not something you would really be able to just dig a hole into to find clay. It's really, one other thing we want to mention is that we don't recommend digging near roads or steep slopes like this for obvious safety reasons. Obviously the pollution that comes off a roadway can become, held within clays and contaminate the clays. And steep slopes, it kind of goes without saying, if you're digging from the base of this, you're kind of creating a dangerous situation where a rock slide could occur.
Yeah. Some other useful things to be on the lookout for when you're in the field are cracked soils. Clay-rich soils will often crack when they dry because of the fine particle size of the soil. So a deposit like this might not be pure clay, but it could be screened in the studio to remove some of the plant material and some of the larger stones and sands in there. And that can help increase its workability too. Certain plant life can also be a good indicator of clay. So plants like horsetail, like like you see here, cattail and other aquatic plants, they thrive in consistently damp soils. So it's not always the case that you'll see these plants growing in clay, but if you see these plants growing, it means that the soil is very moist, and there's a chance that that soil could be clay because it holds on to and retains moisture for longer than other soils. In winter, or really in kind of the fall period before you get a lot of snow on the ground, ice crystals will grow on really clay-rich soils as the groundwater freezes. So, of course, you have a very limited time period where you can actually see ice crystals growing like this. But yeah, you might want to consider checking out your property before the next freeze this year. One of the biggest questions we get in these workshops is, how do I know if this is clay? And really, our answer is pretty simple. If it feels like clay, it probably contains some clay. If you're ever in doubt, take a pinch. If you can kind of pinch a bowl with it or roll a coil around your finger without it cracking or slumping, then it probably contains clay. And it's just important to keep in mind that the clays you find out in nature are not going to be as pure as commercially prepared clays. But you can always kind of mess with them and
blend them
and screen them in your studio to make them a little bit easier to work with. When you are ready to collect in the field, the first thing you should do is always ask permission. Never take from private property unless you have the express permission of the landowner, and never take from a state or national park or other protected land. When you are collecting, we usually just bring some very simple materials into the field with us. We bring a few 5-gallon buckets, some feed bags, which are just these woven plastic bags. They're a little stronger than other bags. Or feed bags or sand bags. It's really the same material. We find that it's a lot easier to move many small containers of clay than it is to move one really big container of clay. So do whatever you need to do to take care of your body and not put more stress on your body. And we find that it's easiest to dig clay when the soil is just slightly damp. So kind of like in this image you see of me digging here, that clay was just a little bit damp, but not soaking wet. And we like to dig when it's a little bit damp to cut down on dust, but also it's a lot easier to get your shovel into the ground. You don't want it soaking wet because then you're just digging heavy material and transporting a bunch of excess water that you're just going to have to dry out when you get to your studio anyway. So yeah,
if possible, try to time it with the seasons just to make it easier on your body.
Mm-hmm. So after you've located the clay and brought it back to your studio, the next step is to begin testing it to learn a little bit more about its properties. For this next section, we're going to shift gears and share some of the clays that we like to use in our studio. But before we begin with that, we're going to exit out of this and take a moment to answer any questions you might have so far. If you don't have any questions yet, that's okay. I know it's kind of
a lot of info.
Yeah.
I have one.
Yes.
Sure.
Do you have any, I don't know what it's called, dogma, or do you, about how much you will blend your clay with the collected clay with the other types of, I don't know if you buy clay and mix with it, or do you think about how much you want to mix?
Yeah, it depends on the project.
Mm-hmm.
Something like a restaurant commission, though it might require work that's much more durable, more, stronger and less likely to chip and crack. So in some cases we add a little bit of feldspar just to make the clay more glassy.
Yeah.
But we've gotten to a point where we were able to blend different materials together, different wild materials together.
Okay. Okay.
So yeah, we don't have to use too many, different commercial clays to supplement.
Yeah.
However, porcelain is kind of an exception.
Yeah, I do. I still use commercially purchased porcelain for certain bodies of work because I really like the way that some of my local materials blend with the porcelain. I really appreciate the look of it. And the materials we have in our state here they're not pure enough. They're not as pure as the porcelain that I can buy from the store. So I've tried making my own porcelains here and they're lovely, but not quite what I want. So that's why I do still purchase those.
Yeah. Okay.
Yeah.
I have a question. I'm finding it so ironic, and I guess I've been just naive or not realized it, but I'm so inspired by rock formations. Isn't it ironic that I'm taking material and mimicking what it came from? So I'm curious, when's the moment where it's not I understand this process, but is there a defining moment where something isn't a rock, it's clay? Because it's sounding like they're the same in different forms.
Yeah.
Is that right?
So if you ask a geologist what is a clay, they will say it's a rock. It's just a mineral. It's not it's one single free moving mineral. It's not like a mineral that's bound together chemically in the larger rock. But the physical process of weathering from a rock into clay it's always a gradient. And there might be some point where someone says, okay, now it's clay. But I think ultimately it's when it has clay-like properties, when it becomes plastic and workable.
Yeah, I think that's our definition of
Yeah.
when it becomes clay, because technically the technical definition of clay is what Mitch just said. You can still consider it a rock at that point. But yeah,
it's kind of interesting. Everything, you start off thinking about everything in a box. This is in one box and this is in another box. But the more that we have learned from other people and geologists, and just by, sort of pursuing this, is that everything's just on one spectrum. And, it's just many things kind of lined up next to one another, which is really fascinating.
any other questions? Okay, so we're actually going to take a little break here. I think we're going to do 10 minutes. So during this break, you can stay logged in. Mitch and I are just going to mute our microphone and the camera as well. But we'll be back in 10 minutes. So for us, it's going to be 2:05 at that point.
Yeah.
Or yeah, about 2:05.
All right, we'll see you soon. Thanks.
Okay, we're back.
Welcome back.
We might be back a minute early.
Yeah, we'll take things slow.
Yeah. So first, we're gonna go ahead and talk about some of our favorite materials to use, but we're going to be talking about them as if it was the first time we're using them. So all of these materials are raw out of the ground. All we've done is add enough water to them to make them workable.
Yeah. So our goal with this is is something that has kind of been the result of a question that we get a lot about these workshops. And it's that, you know, my materials are going to be very different. Will this still be relevant to me? And, you know, obviously the answer to that is yes. Everywhere is going to have slightly different materials. But what we're hoping to do is just share the whole process of how to, you know, take these things out of the ground, you know, look at their properties, make some guesses about how you could use them, and then make the tests to figure out how you can use them in ways that make sense for your work. And so the first step to that is just, you know, we just call it like the initial testing stage. And this is really the most exciting time because, you know, you're really just getting to know a material that you are kind of unfamiliar with. So we're just going to kind of bring you along on that step of the journey.
So we're going to kind of go in order from this clay down to this clay at the end. I'm going to
the raw first.
Oh yeah, sorry. So I'm going to show everyone a raw sample of this clay before we added the water. So this is what it looks like. It's very dry and crumbles very easily. You can see it's beautiful, like stark white, but when I rub it between my fingers, I can feel there's some very fine particle sizes and then also some larger pieces of grit in there, kind of mixed in. So yeah, just really crumbly, kind of small, doesn't really hold together at all.
Mm-hmm. So just based on that initial observation and everything that we kind of went over, what would you guess that material is? And how would you guess that it's, you know, how could it be used? Anybody have any guesses?
Kaolin?
Well, yeah.
Kaolin because it's white?
Yeah. Yep. So we would say the same thing because it's so pure white and it's so crumbly and it has those large pieces of grit, which is from the quartz. We would also say this is a kaolin clay. And because it's a kaolin clay, we're anticipating that it's going to be a little bit more refractory. So that just means that it will need a higher temperature to reach vitrification. So having access to a kaolin material like this can be extremely useful in your studio because it's easy to find low temperature firing clays. But if you do have access to some high temperature clay, whether it's kaolin or another high temperature fire clay, you can always blend it with some other low temperature clays to make them a little bit more workable in the studio. So yeah, we would say probably kaolin. Should we talk about?
Yeah. So then beyond the initial, you know, raw clay, the next thing we like to do is just, you know, add a little bit of water. So we often just carry a jug of water with us in the field and just kind of wet down clay samples and just kind of pinch them and see how they feel.
Yeah. So you can see even just tearing it off of this block, it really tore in a very crumbly way, very similar to how the dry material acted.
Yeah. And just to kind of emphasize that sort of crumbling, I like to just take my thumb and just kind of drag it across the surface. And you can kind of see how it breaks apart like that. So that kind of feels very common with what we recognize, you know, non-plastic clays acting like. So that sort of, you know, loose, crumbly crackiness, you know, is a very important quality in those refractory clays.
Yeah. So I have just rolled a coil of this clay, and now I'm going to try and wrap it around my finger to get a sense for its plasticity. And you can see this clay does not want to wrap around my finger at all. It just doesn't have that working property. It doesn't want to hold together when it's bent by itself. So
refractory is less plastic, correct?
In
not
general,
always?
in general, it's kind of like materials that are refractory tend to be less plastic, but they're not less plastic because they're refractory.
Mm-hmm. This clay, it's a little bit less plastic because it still has so much of that quartz in it, because it hasn't been screened or anything. So it's a little harder to work with because of those quartz particles.
Yeah. So we don't often, take a wheel like this with us when we're out foraging for clay, but when we bring samples back to the studio, the first thing we like to do is sort of test them, based on the way that we work. We both do a lot of hand building,
Mm-hmm.
and so it makes sense to see how a material works by hand building. So just kind of quickly coiling this piece here. You can kind of see that the edge is really ripped up quite a bit. When I first was making this, it was quite, cracked apart, and then I kind of pressed it together. But just by kind of bumping this out, you can see how eager it is to just fall apart.
Mm-hmm.
So that is, probably the best example of a low plasticity clay. However, if your goal is to make work that sort of references the sort of cracked, craggy textures of earth, that's a great material to have. And so, just because it's non-plastic doesn't mean it's good. That's all relative to what you want to do.
Yeah. And so, Mitch, were you pinching that or coiling it?
Yeah, pinching.
Okay, yeah. So here's another example of a pinched form, just done by hand without any sort of base underneath. And you can see it doesn't want to hold together by itself. When you are doing these kind of hand building tests in your studio, like Mitch said, it's a good idea to test the working properties of the clay using techniques you're already familiar with, whether that's throwing or coiling or pinching. But you can also try some other techniques to see if you can figure out unique ways of working with a material that is a little different from how you would usually work with it. So a clay like this that's kind of impossible to work with by itself might lend itself well to being used in a press mold. So here I have just a little bisque fired press mold that I've made. And by compressing the clay with my finger against the edge of the bowl, I can really start to eliminate some of those cracks, and it might hold together a little bit better.
So Zoe, did you all say you've not processed this at all? It just has water added to it, correct?
Yes, that's correct. We might have removed some large sticks that we could just see, but we haven't screened anything, any of these 4 clays yet.
Okay.
We'll talk about the processing later. This is just kind of the first steps to figure out, is the clay workable by itself before we do anything to it.
Yeah, because ideally we would do as little processing as possible. So this is, this tells us how much we can get away with, so to speak.
And did you mention earlier that you believe this is a high fire clay, or it's and you assume that because of its kaolin, or what kind of agreed to that?
Yeah, we're assuming that it's a high temperature clay. One, because of its color. It looks like it doesn't have any iron or other mineral impurities that would lower the temperature. So the color is kind of a big indicator that it's probably kaolin. The fact that it has those really large quartz sand is another indicator that it's probably kaolin. And just the consistency feels like raw kaolin.
Yeah, the low workability.
Mm-hmm.
And unfortunately, our favorite thing, something that we can't share with you over Zoom like this, is the smell. It sounds crazy to say, but primary kaolin has a remarkably clean, almost astringent smell.
Yeah.
So it doesn't smell like, dirty, soil, like damp.
Yeah, it doesn't smell like a pond. Like this clay smells kind of like a pond to me.
It just smells clean.
Mhm.
And I don't know if the smell is because of this, but potassium feldspar is acidic. And so in nature, when you have like a pond that forms over granite, so a lot of granite quarries, when they fill up with water, that water is often like a very bright blue. And that's because the acidic quality of the feldspar makes it difficult for organic matter and plants to live. And so it's basically just very low plant matter in this.
Mhm.
And so you're really just smelling the rock,
Yeah.
which is such a wonderful way, to kind of form an experience with these materials.
Yeah.
Question about feldspar. So this is kind of really out there, but it has high UV properties. Have you guys ever experienced with any of the UV properties or experimented with the UV properties in any of these minerals?
No, that's interesting though.
That's something I've kind of been collecting stones along that line, and feldspar is extremely, like, will have lines in there of high UV. So it's something that kind of intrigues me as far as attempting to incorporate, and I have no idea how the firing process. A lot of them are like thermoreactive as well, so I think it would hold up and under firing, but just wondered if you'd heard of anybody experimenting with that.
No, that's brand new to me, but
Yeah.
I love that. I wonder if it has anything to do with the, because the feldspar, the crystal is very like.
Gotcha, the way it lays. Yeah.
Yeah. So.
Oh, I didn't consider that. So if you crush it, it may ruin that.
Yeah, probably down to if you crush it to a very small size, it might lose that quality, but even, small grains, they still break apart with the same cleavage,
Gotcha.
that kind of blockiness. Yeah.
Yeah.
That's fascinating.
Yeah, it's something I hope to play with. So yeah.
Mm-hmm. Yeah. That's cool.
Yeah, very cool.
Yeah, so this kind of powdery coating on the hands, that's kind of, something that really only primary kaolins do. So yeah, kind of based on these properties, we could make the assumption that this clay could be fired to a very high temperature, but we wouldn't know until we test it.
So I'm actually going to switch to this next clay here.
Oh yeah.
And so the next clay that we'll be testing the properties of is this here. So you can see the color is dramatically different from the last clay. The last clay had that bluish white color, and this has a really nice kind of warm yellow ochre or orange color. But it has similar properties in the dry state where it just wants to crumble. And it has that gritty feeling between my fingers. Like I can feel some pretty large pieces of sand in there. So yeah, it's a little different. You want to take that?
I don't know if I do. So just to kind of show this sort of cross section of what Zoe just pulled out, you can kind of see the wide variety of sand and large stones in there. So just right out of the ground, this is an incredibly gritty material.
Mm-hmm. The stones do feel a lot larger than in the last white clay that we used. The last clay, it was all pretty consistently the same size, but this one you can feel there's some sand and there's also some large pieces of something in there. Like this is just one rock here. So yeah, a little more variety in texture.
Yeah, so this clay is a little bit on the dry side, and that could be contributing to, how excessively it's cracking. But this is kind of a nice state to work in if you want to make things that have a cracky, sort of earthy appearance.
Yeah. I think this clay could use a little more water, but even if it had more water to it, I don't think it would want to wrap around my finger. It's just not cooperating with that that test to see how plastic it is.
Yeah. So I'm going to attempt to coil something. Oof. It's like trying to coil wet granola. So again, the texture is great for certain earthy qualities, but the workability is pretty low.
This would probably be another good candidate for a press mold. Just based off of its very limited workability here. Press mold or blending it with a waxier material.
Yeah. One thing that kind of goes through my mind when I'm working with a clay like this is, okay, in its natural state, it is extremely challenging. But what would it be like if it were, screened? What if we removed all of these coarse rocks? So that's kind of the next step. But just in terms of the initial step, this kind of falls into the same category as that last clay. Anybody want to venture to guess what this clay might fire to, or anything about its history?
Would you call it do you think it's a fire clay?
Fire clays actually, so fire clays are refractory clays. They tend to have a little bit more iron. But I think that there's a very unique environment that only fire clays occur in, and they occur in close proximity to coal.
Oh, right. Okay.
Yeah. So I'm not the most knowledgeable about fire clay specifically because we haven't lived in any place where we've had access to them. I don't know if anybody here does.
But they tend to be a little bit more workable to a fire clay.
Yeah.
So I'm thinking that this clay is probably a stained kaolin because it has properties that are very similar to the white kaolin that we were just using. So I'm thinking this is probably a stained primary clay that has ochre or some other like iron bearing mineral kind of staining the clay.
Oh, that's so interesting because I wouldn't have thought of that just purely because I never thought of kaolin as not being white. So I didn't realize, I was just reacting to the texture and or maybe I don't know enough. Maybe the texture also could be the same with earthenware clays, but I didn't realize that kaolins can be stained.
Mm-hmm.
Yep. Yeah. So that's kind of why we wanted to show this one because I think like a lot of people, you're similar to a lot of people in that kaolin tends to be thought of as this really pure white material. But what we've found in the field is that it actually comes in a range of colors.
Mm-hmm.
And yeah, it's true that certain warmer colors tend to make people think that the clay fires to a lower temperature. So if the clay is orange, red, brown, people automatically think that, oh, I can't fire this clay very hot. But when Mitch and I were working in Virginia, we actually had access to this bright rust red clay that was a super high temperature clay. It was maybe cone 12 on its own.
Yeah, it was very refractory.
So it's not always that color always tells you the firing temperature. Sometimes you get pleasantly surprised.
One other thing to kind of mention both about this clay and the previous clay, we will mention that both of them were found in an area where there was a lot of granite and granitic rocks. The previous white kaolin was found near a source of granite that is more, as you might imagine, lighter in color, kind of like a white to clear granite with not a lot of iron. This one, however, is found near a granite that has a lot of those black streaks, the mica. So does anybody remember what that darker colored mica was called?
Biotite?
Biotite.
Yes.
Yes. And the clay mineral that biotite weathers into.
Anyone remember that? It's okay if you don't.
Muscovite? No.
Well, I think chlorite.
Chloride. Yeah, but muscovite weathers into illite.
Yeah.
So that's the other kind of mica.
All the ites.
Yeah, a lot of ites to keep track of.
Yeah. So sorry, go ahead.
Oh, I'm sorry. So the granite that we have here has large pieces of biotite. I mean, like I've seen it in a couple inches long. But then also I looked up on the maps that you were referencing, the USGS maps, and there were also garnet and tourmaline. I found garnets. Do you find that? Is that common? It looked just like the white with the black, the salt and pepper.
Mm-hmm. Yeah, it can be quite common for those rare minerals, rare gems to form in granite because granite cools very deep beneath the Earth's surface over a very long period of time. And those minerals form under those conditions. So a lot of pressure, a lot of heat, and a lot of time. So it is quite common to have different kinds of different kinds of granites that have those types of minerals in them.
Mm-hmm.
You mentioned chlorite just now. How does salt factor into all of this? Like in a salt firing, doesn't is it chlorine and salt? One burns away and the other fluxes the clay, right?
Yeah.
To create almost its own glaze. So does that relate to any of the ingredients or properties in these clay bodies, so to speak, or these secondary clay?
Yeah, that's a good question. Chlorite is different from
Chlorine.
Chlorine.
Yeah.
They're related, but
Well, I don't think they're related.
they're not? Okay.
No.
Just kidding.
So chlorite is just it's consisting of mostly four elements, 5: silica, alumina, oxygen, and then it comes from iron and magnesium rich rocks. And so those iron and magnesium, that's what kind of gives it that darker color. Sometimes it's like a green, which in the case of this, kind of makes sense. But yeah, sodium chloride salt is a separate.
So you guys said both of these kaolins were found near different sources of granite. Now, is that my question, and this kind of went back to earlier, is near a lot of granite deposits, are you going to find a lot of clays, or is it more likely you're going to find kaolins? So I guess when you're going back to looking at those maps as well, when you're thinking about it, are you going to find these different kinds of ones, usually different kinds of clays typically associated with those rocks more often, or is it kind of just, where you are in the world? Does that affect it more so?
It's a little bit of both.
Okay.
Chemically, so it has a lot to do with the minerals that are in the rock. So granite, is the rock, and granite is made up of feldspar, and that feldspar weathers to kaolin. Other types of rocks might be higher in the mineral biotite, which weathers to chlorite. And so the different minerals that are present in different rocks are going to weather to different clays. But in general, granites are very high in feldspar. And so granites that weather through hydrolysis are high in kaolinite. Does that kind of answer your question?
Yeah, absolutely. When you think about the science of the rocks breaking down,
Yeah.
that makes perfect sense. So
Yeah. And then in terms of, other factors beyond chemistry of the rock, you know, obviously I mentioned that, you know, the process of hydrolysis, that weathering, it only occurs in specific parts of the world that have higher levels of humidity, you know, higher moisture, higher temperatures. It could also be the case that, you know, for instance, like Norway and Sweden, there's a lot of granite up there, and it's been so heavily altered by glaciers that if there was kaolin, a lot of it has been pushed south. And so that's kind of common, you know, here in Minnesota, there's not a lot of kaolin on the surface. It's all been pushed south into, you know, Iowa and, you know, pushed into the Mississippi River, mixed with everything else and then washed away.
Mm-hmm.
So it's a matter of the right chemistry, the right place, and the right time. Good questions.
This is a really probably dumb question. You're talking about north, south, east, west, not up to the sky and down to the earth. Do all rivers run south towards the south?
I don't
You're
think so.
saying that the things run south on the map.
Oh, we're talking about the Mississippi River specifically,
Yeah.
just because that's the main waterway in Minnesota.
Yeah.
I know there's a few exceptions to the north-south rule for the way rivers flow. Like I think the Nile flows north.
Okay.
It just depends on the topography, you know, whatever path is. But just in the case of glaciers, you know, when glaciers sort of moved into Minnesota and much of the northern hemisphere, it was from a north-south movement.
Mm-hmm.
Yeah.
Okay, so we're gonna keep going and showing you guys some other clays here. So I actually switched these. We're gonna talk about this black clay next. This is an example of the black clay pure, without any water added to it. You can already see that the chunks of this clay are much larger than the other two clays. So it wants to hold together more just naturally. And when I try to break it, it does take a little bit more effort to break. It still crumples pretty easily, but yeah, relatively easily. I could definitely hit this with a hammer and it would shatter, but just a little different. And then the color, much darker, really lovely black color to it. And
So we'll throw this question out to the group. Can anybody speculate why this one is much harder to crush than the other? What do you think that comes from?
Particle size, probably.
Yes.
Yeah, so it's finer.
Yep, exactly. So it has, you might be able to tell, like if I kind of rub this clay a little bit to make it flatter, it has a sheen to it that the other clays didn't have. So it reflects light and it looks kind of like a ball of wax at this point. The particle size is much finer. And because it's finer, when they're dry, they hold together a lot more, and it's just difficult to break through that.
Yeah, so just kind of looking at a chunk of this, there's still quite a bit of material in there. There's one really big thing. And then a lot of, you know, light colored things. We're always keen to look out for these lighter colored specks because we speculate that this could potentially be limestone. Limestone consists of calcium carbonate, which is a bit of a problematic material if there is like a pebble of it or a grain of sand in your clay. It's a great glaze ingredient, but in terms of like a grog or a sand, it can lead to a lot of problems. And so we will talk about limestone and other calcium carbonate issues shortly.
We'll do that in a few minutes. So just my initial test with this coil, it's still breaking a little bit. I think this clay needs a little more water, but it's starting to hold its shape when I coil it around my finger. So finally, we have a clay with some plasticity to it.
But it's got a nice balance of plasticity while still being kind of, cracky.
Mm.
But what's really nice about this is it kind of holds its shape. Those previous two clays, when I kind of pinched this shape and then wobbled the rims, it just became really loose. And that's another thing that you'll commonly encounter with more primary clays. They just don't really have the structure to hold together.
Mm-hmm. Has anyone else experienced that? If you've worked with porcelain before, have you noticed that if you kind of like gently jostle it, it'll kind of almost turn to liquid?
I refer to it as cream cheese when people ask about it. Yeah.
Exactly. Does anyone know the really difficult to spell word that defines that property? So it's kind of like if you mix cornstarch and water, or a really silty material. If you don't know what the word, it's okay. I'll type it.
Thixotropic.
Yes, thixotropic. So I'm adding it to the chat for everyone to see. But yeah, it's just that property of a material when mixed with water, where if you add pressure to the material, it'll stay almost solid. But then as soon as you like just gently move it, it will turn almost back into a liquid. And porcelain tends to do that. Certain porcelains will do it more than others, depending on the recipe that they're made from. And then other primary clays do that a lot. It's also something that happens with like if you're mixing Custer feldspar or another feldspar or nepheline syenite with water. Those are materials we'll talk about in more detail tomorrow when we discuss glazing. But those materials want to settle out in water. They don't want to stay in suspension, and it's kind of for a similar reason. So here is an example of the pinched bowl. You can see that it really holds together really well. The edges are slightly rough just because I didn't take the time to smooth them down, but I could very easily smooth these edges down with no cracking issues.
Yeah. We love this material, just working with it in the studio, because it like Zoe mentioned, it kind of reflects light and it has this waxiness to it. But it also has working properties that both of us really enjoy. Mm-hmm. Like I mentioned, the balance of plasticity with texture. So this piece or this clay coiled pretty easily, and it kind of holds that shape pretty well. Clay feels nice and dense, kind of waxy. So based on this sort of color, this sort of jet black color, the pretty high level of plasticity, could anybody guess anything about this clay's origins or what it might be?
High in carbon, maybe? I mean, guessing on the color too?
Yep.
Yeah.
Yes. This clay was found near the bottom of a lake, right?
Near an ancient lake.
Yes. Yeah. So yeah, it does have a high carbon content. You can definitely smell it when you're working with this clay. It smells a lot, thank you, a lot swampier.
Notes of swamp.
Yes. And it does not fire black. So that's another indicator that the black staining is not coming from a mineral, but it's coming from carbon. So the carbon will, of course, burn off in the kiln. Any plant matter or any other carbon material will always burn off in a kiln. But if this were stained black from something like manganese, it would probably stay black when being fired in the kiln.
So we should mention.
What color does that clay fire to?
We
should guess. Anybody want to guess?
I mean,
it's
it could be any color really, but it fires to this really lovely brick red.
Oh,
Yes.
We'll talk more about it in a minute, but this is a fired example. So kind of a nice maroon. Yeah, it's just a beautiful clay that we use a lot.
Yeah.
There
I just want to say one thing. There have been instances where we found a material in the field where it was a jet black clay, beautiful working properties, really waxy and plastic. And when we've fired it, it came out completely white. So that's just another example where the clay is stained with carbon. And we know that because the black carbon burns out. But then there was no other trace mineral inside the clay to stain it even throughout the firing. So yeah, kind of a nice surprise.
So that last one was a ball clay then?
Yeah.
Yes.
Yep. Yeah. Ball clay forming in an ancient sea, actually. So much of Minnesota during the Cretaceous period was underneath a shallow sea. And so all of the sediments kind of accumulated in that area. And it was often, there were a lot of parts of it that were kind of swampy. And so within that clay deposit, that specific layer, there are also lots of fossils where you have these fragments of shale that have leaf imprint fossils and sticks. So all different things, from when plant matter had sort of, fallen and become buried. A lot of the time that material, it becomes converted into something that's called lignite.
We're going to type it in the chat.
But it looks very similar to charcoal. However, it's not burned. It's just, organic matter that has been, compressed and then basically just converted into carbon. And so a lot of ball clays occur in areas where there's also this lignite.
Yeah. Okay, so our last raw clay that we'll talk about before moving on to producing tests is this clay. So you can see in the dry, unprocessed state, once again, the chunks are a little bit larger than we saw with the first two crumbly clays. And this one breaks apart, but when I break it, it doesn't produce any crumbs. It just breaks pretty cleanly and makes these really sharp edges.
Yeah, so you can kind of see it just breaks to a really fine edge like that.
And the larger pieces are very difficult to break. I don't think, I'm not going to break this on camera, but maybe with a hammer, I could break that up.
Just kind of initial observations. It's obviously, very high in iron, considering the red color. It does have a lot of small stones, and it kind of seems like the stones are all somewhat rounded. Nothing has a really sharp edge to it. I'm noticing that it is extremely waxy, so waxy that it actually records my fingerprint. I don't know if you'll be able to see this with our camera, but I'll send a close-up photo. But that's something we like to do when we're trying to figure out how plastic a clay is just see how much of your fingerprint it will record. Obviously, that first clay we worked with, that primary kaolin, it could barely even hold a thumbprint without cracking, but something like this, because it's so fine grained, is just going to record more details.
Coils beautifully. It does have a little bit of cracking. Might need a little more water, but it really holds up very well in the in that test, the plasticity test.
Yeah, so even though it feels like it's a very fine-grained clay, it's still possible to, kind of stretch it in a way that creates some cracks. So might be interested to kind of see how easy it is to smooth those cracks out. Obviously, the smoother you can get it, the more plastic it is.
I'm noticing as I'm pinching this little bowl, I can get it extremely thin. That's another indicator of good plasticity, is how thin can you pinch the piece before it starts to completely fall apart. And I'm actually going to cut this in half so you can see how thin it is. If I can find a knife. Could she pass me the wire?
Yeah.
Yeah. So you can really get it very thin. Could probably even go thinner. But there are some large stones in here that are preventing me from going too much thinner.
Yep. So kind of same situation for me. Just great plasticity, lots of organic matter. This looks like it's a piece of partially decomposed, I don't even know, tree bark maybe? Any other initial observations?
No. Anyone have any guesses as to what kind of clay this might be? Okay, come on. Or how it was deposited, maybe? We gave one clue about the rounded stones in the that were mixed into.
Yeah. So what if I said
The
this?
river.
This would be pretty common for a clay deposited by water, just because the fine particles would be transported further by the river. What if we said that this came from far northern Minnesota?
A lot of people might not be familiar with Minnesota's history, but Minnesota and the Great Lakes region are kind of formed by glaciers, glaciers that used to exist many years ago. And so this clay is a glacial deposit clay.
Yeah, so this clay is actually, this is the topsoil. This is what lies directly below the organic matter from trees and grass in a lot of areas. So northern Minnesota is very abundant, has very abundant clay deposits like this. And yeah, so it's just kind of a really great resource. The red color is obviously really nice to have because it's a kind of a contrast to some of the lighter colored clays.
Okay.
Was some of the geology of Minnesota why you chose Minnesota to live?
Not really.
It's kind of an afterthought.
Yeah, to be honest, it was an afterthought. We ended up moving here partly because there's a great ceramics community in the state already. So a lot of other people here are working with clay, or they have wood kilns, or they're just in the arts in general.
Mm-hmm.
And then Mitch also has family in the area. And really one of the main reasons we wanted to move here from California was that it's much more affordable to live here than it is in California, especially where we were living kind of in the north near San Francisco. So yeah, there were many factors that went into us moving here, but geology wasn't really one of them until after we got here. We were just, I guess, kind of hoping that we would find something, and luckily we did. So now we're going to talk about some of the initial fired tests of these.
Oh, wait, make the test first.
I need to make the test first. I'm so sorry. I'm scatterbrained today.
So after we do those initial working property tests, we have a good idea of how we could shape the clay, but we don't know how it's going to respond to heat. And so the next step in our process is to just make these initial test bars, which are, they kind of give us the first information on how the clay can be fired.
So when we make these initial test bars, we are doing it with the complete raw clay. We're not screening anything ahead of time because we really want to see everything that's in the clay and how it affects the overall clay. So to make a test bar, you have a few different options. You can roll out a slab and then use some kind of stencil to just trace around to make a consistently sized bar of clay. Or you can use this idea of like a press mold. So this is just a bisque fired slab that we cut a shape out of, and it looks like a cookie cutter, but we're not actually going to press this into the clay. We're just going to press the clay into it. Mm-hmm. Could you actually get one of the plaster bats? And I like using this press mold method because some of the clays we work with, as you could see, don't have a whole lot of plasticity, and they might not roll out into a nice slab. So using this press mold method really allows you to create a consistent bar. So I'm just taking a chunk of clay and just pressing it into shape.
You can make these whatever shape you want. We are making these as long rectangles because we're going to inscribe a line on them that we can use to calculate how much the clay shrinks during firing. If the shrinkage is not important to you, you could make these test pieces as actual forms, whatever shape you want.
Yeah, it's a good idea to make a test bar or a test piece with enough surface area that you can actually see what's happening though. If you make these little clay buttons, it might give you a good idea of color, but it won't have all the information there. So now after pressing all this clay into my mold, I'm just going to use a little piece of wood or a knife, whatever you have on hand, to just scrape the surface flat and smooth. And I think I'm actually going to leave it with that nice texture because that can be another good piece of information to see how this texture remains after the firing process or how it gets changed by the firing. And you also get on the opposite side some other unique texture from using the press mold. So you can see how it cracks at the edges there, which is kind of lovely. So now I'm just going to very gently kind of pop this out of the mold. It might take a little bit more wiggling depending on the clay that you're using, but this one popped out pretty easily. And so now I have this nice bar that holds together, and I'm just going to measure a line onto the bar and then label the clay. Mitch and I, when we first encounter a clay, we usually label it with just where we found it. So we have a lot of clays with like place names, and we just keep referring to it as that place name. But label it however it makes sense to you, just keep notes. For our test line, I am using the measurement of 3 inches, which I know makes 0 sense. I should be using 10 centimeters for everything because it's much easier to calculate the shrinkage percentage from 10 centimeters than it is 3 inches.
I'm the one who's responsible for that.
But this is just the way we started doing it. And I don't know, it's just what we're going to keep doing. So let me show you. I literally just measured 3 inches and put a line on either end. That way, after the piece dries and is fired, this line will shrink, and I can just measure between those 2 points again to see how much it shrank by. So
this would be useful information if you're making like a custom, tableware commission where, the chef or the client wants things to be a certain size. So you can just calculate, how much larger you need to make it to accommodate for that shrinkage. And you can do this with any clay body. It doesn't have to be local materials. The information still applies.
And it might be difficult to read my handwriting, especially since it's backwards, but it just says raw Acme. That's where we found the clay. And I'm writing raw on there. That way I remember later on that this clay has not been screened at all. I could make another test bar just like this after having screened the clay through window mesh. And then I would write like window mesh, Acme, or I could do another test bar where it's been screened through an even finer mesh, like 220 screen. And anytime I screen a clay to a finer consistency, I just want to make sure I keep track of it. That way in the future, when all my test bars are mixed up, I can find one and figure out exactly what I did with it. So it's just easier to keep track of. Now at this point, you have this bar of clay and you might have no idea how it's going to react in your kiln. So a way to protect your kiln, whether it's your personal kiln or if it's your community kiln, is to make a little test boat. And this is just very simple. It's a little tray with very shallow walls here, where you can put your bar of clay to fire. The test boat needs to be made from a clay that you already know and trust. So a high temperature clay, whether that's a commercially purchased clay or a high temperature clay that you've already tested in your studio. It could be a local material, it doesn't matter. You can also just, I don't know, this is an example of a test boat where it has no walls, it's just completely flat. We don't really recommend using a flat test boat for your initial test because you might run into an issue if your clay bar decides to completely melt. So with this test, we are very grateful that we put that little lip on there, and we actually probably should have made it a little larger because that clay just completely melted and started to come over the edges.
So just to kind of give a sense of the relationship, this test that kind of blew up like this was originally the same size as that. So when you're testing something for the first time, it really doesn't hurt to err on the side of caution and make a really big, sturdy test, especially if you're working in like a communal studio. Mm-hmm. Yeah, this is kind of a good example of a heavily fluxing clay. This was fired to cone 6 in oxidation, and it, it was just way overfired, and so it's beginning to flux and melt and bubble.
Mm-hmm. The test boats, whenever you make them, they can be, I'm sorry, what is this called?
Raw?
No, not bisque.
Green?
I'm losing my mind. They can be green clay. So this is just unfired clay. They can be fired up to cone 6 or cone 10 already, or they could just be bisqued. It really doesn't matter as long as there's nothing else on it, like no other glaze, and no other glaze or stones on your test boat. You can keep reusing them multiple times as long as you can just remove the old bar. Obviously, with the really melty ones, you're not going to be able to reuse them. But
yeah.
And
we fire the tests all the way up to cone 6. We don't bother bisque firing them. We just make sure they're good and dry, and then we just take them through a slow firing, which is what we do for all of our firings. We aim to do once firing for everything. It cuts out energy, cuts out time, cuts out the number of times we need to move something and risk breaking it.
Yeah. We can talk a little bit more about once firing later on in the workshop, especially when we get to glazes, because I think people have a lot of questions about how to glaze when you're once firing, but we'll cover that tomorrow, I think. So
yeah. So once this is dry, we just load them in the kiln and we fire them to the temperature that we know we want to fire to.
If you're if they have rocks in them, would you ever put them in a sagger, or is there any need to put like a lid on it rather than, is the biggest risk that it will just melt rather than kind of explode? Or
Yeah, there are very few rocks that actually explode in the kiln, and those are rocks that are very high in silica. So if you have a piece of like a piece of flint or just a piece of pure quartz, there is a chance that that could kind of shatter. But most of the time, if it looks like it has, you know, kind of like a crystalline structure to the rock, it's not going to really shatter. It'll just eventually melt. But if you want to be, you know, completely cautious, you can certainly, you know, put a lid on something. But keep in mind that if you put that test inside of an enclosed container, it's going to be cooler inside that container than it will be outside. So maybe just do something to make sure that it's like a loose fitting lid.
Yeah, and when we say lid, we're talking about like just a thin, like a slab of clay just resting on top of the test boat. And when you, where's the test? Oh, when you do that, you might want to make sure that the lip of your test boat comes up above the clay. That way the lid is just resting on the test boat and not resting directly on the clay.
Mm-hmm.
Yeah. So then after firing the pieces to cone 6 in our oxidation kiln, we have some fired samples here to show you. And we'll just go through them in the same order that we went through the raw clays. But that first really white clay that was really crumbly, after being fired to cone 6 in oxidation, it stays pure white. As you can see, it just looks like a void on the screen. When I look at it in person, I can see a few little black specks in there, but really, for the most part, it's pretty clear.
Yeah. So
why do a lot of white stoneware clays yellow in oxidation?
it could have something to do with soluble salts that are in the clay. So if you mix the clay with like hard water that has a lot of salt or calcium, those salts, as the clay dries, will migrate to the surface, and then there'll be a very, very thin layer of, you know, fluxes on the surface that might change the color. But the other factor could just be a very small amount of iron. So for instance, this first white kaolin that we shared compared to the kind of yellowish one, you can see that the yellowish one has a much more pink color to it. Let me adjust. Yeah, so obviously just a little bit more iron in this clay. This one, you know, had a lot more texture, and that kind of translates to the texture of the tile. You can see quite a bit more. One other thing to note on this, can you grab your needle tool? Thank you. Is this little white speck right here. So as I kind of poke at that, it sort of releases this white powder. So that is the result of a piece of calcium carbonate in the clay that was fired. So we call that a lime pop out, and we'll explain that in a minute. Mm-hmm. The other thing to note about these two clays is that they're extremely porous. You hold your tongue up to it, and you know, you can feel that it kind of sticks to your tongue. If you don't want to put your tongue on it, that's fine. Just, you know, drop a piece of water or a drop of water on it, and you know, you can see how quickly it absorbs. So what this kind of tells us is that both of these clays are nowhere near vitrified at cone 6. So we could take them and put them in a cone 10 kiln, maybe a cone 12 kiln if we're feeling lucky. Or we could say, you know, these clays have to be blended with something that's going to melt at a lower temperature to balance out, you know, the properties.
Mm-hmm. Oh. So moving right along to the other two clays that we were working with, the really black clay and then the red clay, those fire to a much darker color. So this was the black clay. I think Mitch kind of already showed it. It has a maroon, purple, brown color to it. And it still has a little bit of a sheen even after being fired, just because it was such a tight clay that there's really not a whole lot of cracking in it. The red clay is one of those clays that completely melted into its test boat. You can see that the shrinkage line is no longer visible, or it's still slightly visible, but no longer able to be measured, just because it's so deformed at this point. The clay actually stopped shrinking at some point and started expanding. And that's why it kind of filled the test boat a little bit.
Mm-hmm. So that is called, did you mention bloating?
Mm-mm.
So that's called bloating when something, begins to release gas as it melts, it bloats and it kind of becomes, foamy and porous.
Yeah, you can even see that bubbly texture to it. And it's
Yeah.
even more apparent on that piece.
So this one is just further along. If this clay were to continue being fired, there's a chance it might end up like this.
Mm-hmm. Kind of that lava texture.
Yeah.
That's a sign it's been overfired.
Is bloating a quality of iron?
It can be from high iron contamination, because iron will naturally flux a clay to fire at a lower temperature. So if a clay has a lot of iron in it, it might start to bloat like this because it's trying to melt, really.
It can also be related to sulfur. A lot of iron in clays that aren't visibly red comes from the mineral pyrite. So a lot of ball clay has a lot of, very, very fine grains of pyrite in it. And pyrite is iron sulfide. And as sulfur is heated, it kind of gives off gas and can cause bloating. But another thing that causes bloating is just the clay becoming kind of trapped before all of the gases within it can escape. So if you fire too fast, there's a chance that the pores of the clay become sealed off and the gas can no longer escape. And so when you reach, that temperature where the clay starts to vitrify and starts to give off gas like this one, there's no way for that gas to escape. And so you get those little bloats.
I had thought that when I've seen that texture on clay that I've added iron to and fired in reduction, I always thought it was the iron being pulled to the surface to break away the oxygen molecules. But it looks like that with those little pock marks.
Yeah, I think it can be quite a few things. It can be, just like you said, the iron and getting pulled through the surface, maybe more so in a glaze than in a clay body like this. There are a lot of similarities that happen at different stages and different types of materials.
Mm-hmm.
Yeah.
So would the gases be different depending on the different clays then in bloating?
Yeah, so I think this really dark, black ball clay obviously has a lot more organic matter that's going to need to burn out. So this black clay is more likely to bloat than this, primary kaolin, because this is generally free of carbon. And so we're not as, worried about that. So this black clay, we fire slower than we do this lighter colored clay. Yeah.
I'm gonna move ahead to talking about shrinkage. So I'm just gonna do it for one sample here. This brick clay that we fired, we did the 3-inch line on it. And I'm just gonna use the shrinkage calculation, which is outlined in the clay processing workshop guide that we sent everyone ahead of time. So it looks like this line is actually 2.5 inches now. So the line has shrunk 1/2 inch throughout the drying and firing process. So if you take 3 inches minus 2.5 inches, that gives you 1/2 inch. 1/2 inch divided by 3 comes to
0.16 repeating.
Okay, so 0.16 repeating. Then you can take that decimal and just multiply it by 100 to give you your shrinkage percent.
So 16%.
Yeah, almost 17% shrinkage. That's a lot of
pretty
shrinkage
high.
for this clay. So you might want to consider blending this clay with a clay that doesn't shrink so much. But that's really if shrinkage is very important to you in your practice.
Yeah, if you're looking to just honor the material in its natural state, shrinkage is not really a problem. But if you're looking to conserve materials, let's say it's a very precious resource and you have to use a lot to get something that shrinks down, like Zoe said, blend it with another clay that shrinks less, or add sand or grog, which you're not going to shrink.
Yep.
So we're going to talk about calculating the absorption for these as well. That's another thing that we look at is, how much do each of these clays absorb? That helps us understand if something is going to be, durable enough for food use. We are actually going to do that first thing tomorrow morning because it involves soaking those tiles. But before we move on to processing clay, we want to just talk really quickly about limestone and calcium carbonate. So as I mentioned, calcium carbonate can be kind of a big problem. This particular piece, you can see different sizes of limestone pebbles that have sort of burst through the surface. Sometimes this happens a day after firing. Sometimes it happens years after firing. And if you're willing to look at it with an open eye, you can see it as a beautiful, byproduct of these materials. However, it does often result in the piece, crumbling to the point where it's no longer usable or, stable. Sometimes it just breaks in parts. So other materials that contain calcium carbonate are plaster, cement, gypsum, bone, shells, marble, and then chalk are also calcium carbonate based materials. These can all be ground to a very fine powder and then used as a glaze ingredient. And they're an excellent local resource because calcium carbonate can be found in so many different parts of the world. But as a pebble, it's a bit of a problem. So limestone can be a little bit difficult to identify. In general, it's kind of a cream to gray color, sometimes a little bit yellow. It's often very soft. You can scratch it if you rub it on something that's harder. And because it's soft, in nature, it's often very rounded. So it's rare that you'll find limestone with like a very sharp edge. Usually it's kind of worn down. If you ever find anything with fossils, chances are you're looking at a piece of limestone. Shale also does contain fossils as well, but the difference between shale and limestone is that shale will decompose to a clay and limestone will not. Another good way to identify limestone is just by using a vinegar test. So we have some regular household vinegar, which we're going to put in a jar. Obviously, vinegar is acidic and calcium carbonate is basic. And so combining those two is going to produce effervescence, which is just fizzing.
Like those old volcano projects that everyone did as a kid.
Yeah. So we have 3 rocks here, which kind of, look like they could be limestone. And to do this test, we just kind of drop it in the vinegar and we see if it fizzes. So really nothing coming off of rock number 1. Sorry, I know that's loud. Rock number 2, you can kind of see is beginning to give off quite a bit of fizzing.
It's getting a little cloudy.
Yeah. So that kind of tells me that this is limestone. So if you are approaching us from the perspective of, okay, I have these rocks and I want to crush them and add them to my clay, but I want to make sure they're not limestone, you can do this with the rocks. If you're coming at this from the perspective of, I have a clay that I think might contain limestone, what you really can do is just pour vinegar on top of a sample of your clay. It can be dry clay, it can be a clay slurry, it can be, a workable, consistency. And if it fizzes, if it gives off this, effervescence, that tells you that you have some calcium carbonate in there that should probably be screened out before firing.
You can also kind of pick up some rocks around the area where you're collecting your material. And even if you're not planning on using those rocks in your clay, if you test them with vinegar and they fizz, that could mean that you have some eroded pieces of those rocks in your clay. So it might be a good idea to screen your clay sample if you find that to be the case.
Could you do that test on bisqueware if you think you've included some of those materials? Will it still work?
I think it, I don't know. I've never tried it on bisqueware. The calcium carbonate changes once it's fired. The carbon burns off and it becomes calcium oxide. And I'm not sure if the reaction happens the same. It'd be worth a try.
Is there a way to get it out of there, just like soaking it or something, if you think it was included?
In like bisqueware?
Mm-hmm. Yeah.
You could soak it. So calcium carbonate, when it's fired, it loses that carbon, becomes calcium oxide, but it wants to become calcium hydroxide. So it pulls hydrogen from H2O, mostly in the air, but also in water. So if you soak a piece of bisqueware, it's going to speed up the process, but it's probably not going to neutralize it.
If you soak a piece of bisqueware in water, it's not going to neutralize it. If you are trying to neutralize the calcium carbonate when you have the dry sample of clay before it's been fired, it would take so much vinegar to neutralize it if you have pebbles that I don't think it's really worth it.
Yeah.
Yeah, especially if you have a large batch of clay, it would just be so much easier to screen those pebbles out than it would to neutralize it by soaking it in vinegar or other acid. Plus, then
and it
you'd be working.
It screens out because they're all larger than the other ingredients.
Yep. Yeah. So we're actually going to do a screening demo next, and we'll show you some different mesh sizes of our screens, and that'll, I think, demonstrate a little bit more easily than us trying to explain it.
Yeah.
But yeah, let's see. Any other quick questions about calcium carbonate before we move on to screening and processing clay?
Could you just quickly explain again how it comes to occur in the clay or form in the clay?
Yeah, so we have a large problem with calcium carbonate in our clay here in Minnesota because St. Paul was basically built on top of limestone and sandstone blocks. So just in Minnesota, we have a lot of limestone pollution in our clay. And
pollution.
Well, not pollution, but it's contamination.
Yeah.
And sometimes it's a really fine sand and it's not an issue, but other times those pebbles, if we don't screen them out, then they explode out of the clay.
Yeah.
So Mitch and I have just become extra cautious whenever it comes to screening clay now to make sure that we screen out anything larger than, like a piece of sand, I guess.
Yeah. So the primary clays that we work with that have weathered directly on top of that granite, those do not contain limestone because there has never been a river or a body of water on top of it that transported the fine-grained limestone.
Mm-hmm.
The ball clays that we use and the shale clays that we use, those have all been transported by water, and that process also transports a lot of fine limestone pebbles.
Mm-hmm.
And so those clays are often, they often contain a lot of lime. And the same thing goes for glaciers, just because the glaciers have kind of scoured the top surface. They've sort of mixed up a lot of the more recent, limestone deposits and kind of broken them down into the clay.
Yeah.
So if you live in an area that has been shaped by, rivers, glaciers, and that there is a history of limestone, in that area, chances are it will probably be in that clay, but it's kind of hard to say.
Mm-hmm. Okay, so we're going to literally switch gears here. I'm going to turn the camera so you can see a different part of our studio. And we'll begin by talking about screening and the bulk processing process for clays. And I just want to begin by saying that processing is not always necessary. It really just depends on the materials you have available to you and your vision for how you want to use them. So you can leave your materials very raw if you would prefer, or you can make them more refined. In our studio, we process the materials for two main reasons. Number one, removing that limestone and other problematic impurities like pieces of brick and bark and plant matter. And then we also like to screen our materials in a large batch because preparing everything in a large quantity like that means that you have a consistent material to use. So you know that things will be the same, more or less, firing after firing.
Mm-hmm.
Just because the nature of working with natural materials is that everything's going to be a little bit different between each batch. So I'm going to switch the camera. Okay, bear with us. I know that was kind of dizzying. Mitch is going to fine tune it while I set up. Move the...
A little bit more over here. Back just a wee bit.
Okay, so the first step in processing is drying out your clay sample. So here I have a bowl with some of that lovely black clay that we just harvested from the ground. So it's still in these really large chunks. You might be able to see there's some root material and other plant matter in there. Definitely some large stones and sand is already mixed in. And these pieces, they're so big that I don't think they're gonna slake down in water right away. It would take a long time for water to thoroughly absorb in a piece this big. So what I like to do whenever we get material from outside is to lay it out to dry first. And that might take a day or two, depending on the humidity level in your studio. But after it dries and it gets to this point, then you can put on your dust mask or respirator and some safety goggles. Yep, gonna be so stylish today. And then you can just hit the clay with a hammer. It's best to do this in a well-ventilated space. or outside, ideally. If you do it outside, it's also a lot less mess to clean up. But I'm just gonna lay it out on this old bed sheet here and break it up a little bit with a hammer so it's not these huge clods anymore.
Can you talk about this?
Yeah. So it's really up to you what you choose to use. You know, this is a nice rubber mallet, which is obviously just a little bit lighter. This is a heavier hammer that we use for crushing, you know, more dense rocks and clays. You know, the nice fine point is kind of good when you're trying to break apart things. But yeah, in general, it's just whatever you feel comfortable using. So just the fact that, you know, this clay is crushing so easily is a good indicator that there's probably a lot of fine sand, maybe some silt. What's really interesting is that as you begin to, you know, crush clays that are more fine and fine grained, the actual noise and the sound of the clay breaking apart becomes higher pitched. So, you know, sometimes when we're crushing extremely fine grained ball clays, it sounds like we're crushing a rock. Whereas here, it's just kind of like a dull thud. So it's a full sensory experience.
Wow. That doesn't want to break.
And the more sand that's in a clay, the easier it's going to absorb water and the faster it will absorb water. So if you have a clay that's kind of sandy like this, it doesn't really need to be crushed much finer than, you know, than this. This is a perfectly fine size. However, if it's something that's extremely fine grained, you might find that it works better to crush it even finer. It's totally up to you and kind of what works for you in your studio.
Okay, so now that the material has been crushed to a fine enough size, I'm just gonna put it into this bucket of water here. I know the bucket looks like the water is cloudy. It is. Mitch and I like to reuse water as much as possible, especially since we're working in a city studio and it's not as easy for us to just dump water outside. So we're reusing some relatively clean water that was used in another batch of clay. And I'm just going to carefully take the bed sheet and pour the dry material into the water. And we'll see if that's enough water for this much clay. So now that my dry material has been introduced to the water, I'm a little bit less concerned about dust in the studio. I tried to hold that bed sheet really carefully right over the surface of the water. It even got a little bit wet, just to minimize dust as much as possible. And so now you can see the color of the water has changed dramatically. And I can feel, you know, the clay is already absorbing some of the water, but there's a definite layer of pretty clear water, relatively speaking, on top. And most of the clay has just fallen to the bottom of this bucket. So what I want to do now is let this bucket sit for at least 24 hours to allow that clay time to thoroughly absorb water. And then at that point, we'll start to blunge it. Blunging just means mixing the clay really thoroughly. We use a paint mixer attachment on our drill to do this. And we actually have a bucket of pre-slaked clay, so we don't have to wait 24 hours for that clay to be done. So I'll go grab that.
The 24-hour point is, that's just what we find this clay requires. Every clay is going to be different. You know, like I mentioned, the really sandy clays are going to absorb water much faster. So you might not need to wait as long.
So I'm going to show you guys a trick that we've developed over the years to reduce the mess you get from splashing with this attachment in the studio. So before I add this paint mixer attachment to our drill, I'm going to thread it through this bucket with a hole in the lid, or this bucket lid with a hole. That way you can close up this thing and not have material splashing everywhere. We like to use a corded drill for this because mixing clay, it's almost like mixing cement. It puts a lot of pressure on the drill and it can use a lot of battery to mix it. You can definitely try with a battery operated drill, but I find that you get a little bit more power with the corded one.
You can also just do this by hand or with a paddle, you know. It's totally up to you. This is just a bit of a faster version.
Yeah. I think I actually have to back up a bit because my cord isn't very long. So.
So she's just going to go ahead and plunge this right now. I'm going to mute the mic because it's a little bit loud and our mic is pretty sensitive, but we'll turn it back on when she's done.
So I was trying to move the drill around as much as I could, just up and down and all the way around the bucket to really make sure it's well mixed. Making a huge mess. So you can really see that the clay, it has like this lovely pudding consistency at this point. This clay might even need a little bit more water to screen. Mm-hmm. We'll have to see. You can really screen clay at any at any point with water for the most part. If you add more water to the clay, then it will be much easier to screen, but it will of course take a longer period of time to dry. We could screen at this point with kind of less water, and it would take a lot longer to screen, but be faster to dry. So it's just a trade-off, really, what you feel more comfortable with. I prefer screening when it's on the wet side because it can be very frustrating to have to be screening a clay that just won't go through the screen. I'm going to blend this one more time with this little extra water, and then Mitch will come in and screen.
I would say our ideal consistency for screening in our studio is something like, I don't know, heavy cream.
Yeah.
Would you say?
Probably.
Yeah, we find that that's pretty fast consistency to screen. All right, one more round of blunging.
So depending on your clay and how sandy it is, you might need to blunge a little bit longer than I just did, but you know, I feel like that's okay for this kind of clay. Also, if you are blunging a much larger quantity of clay, of course, you're gonna have to blunge for longer. So Mitch and I, we very rarely make these small 5-gallon bucket quantities. We actually do, I don't know if we'll pull one over, but, oh yeah. So we do this size quantity typically when we're screening clay. So it's a lot more. And we do have to plunge for a longer period of time. You want to go ahead and screen?
Yeah, so I think I'm gonna take over and just kind of take you through the screening process. And to do that, I'll just begin by talking about the different types of screens. This is about the coarsest screen that we use. This is 1/4 inch wire mesh. You can buy it at most hardware stores. It's occasionally called, I think, hardware cloth. And we just built this wooden frame to kind of hold it. And then these outer bars just kind of contain the sharp edges of the wire so that we're not getting cut. But we often use this just as the base. And then we will put a finer screen inside of it. So this is just a piece of regular window mesh. I think it's about maybe 10, I don't know, 10 squares per inch. I know that's not as useful to people outside of the US, but this is great because you can just kind of set it in this trough like this, which is what I'm going to do. Another option is to buy sort of prepared screens. These are great because they can sit on top of a 5-gallon bucket. So you could easily, screen into another bucket without making a mess. We tend to use these more for glazes. So this is a 60 mesh, and then this is a 220. So the 220 is what we use when we're screening things to a very fine size. When it comes to dealing with limestone, we found that if we screen a clay through a 60 mesh, that is fine enough to remove all problematic particles. There are still some other very fine pieces that pass through the 60 mesh. However, those just kind of melt at cone 6. You might be able to get away with something more coarse, but with this window screen, we do tend to find very small limestone pop-outs. So you just have to kind of try, you know, whatever works best for you. But to do this, I'm just going to elevate this this trough onto something so I'm not having to hunch over quite so much. Love this frame because it just sort of fits right on top. And then this is just a pretty simple process. I'm just going to ladle the slurry through the screen. And then there's still quite a bit of large sort of stone fragments in here. So I'm going to try to just kind of gently agitate the screen to let the clay pass through. I don't want to push the stones into the screen because that will then rip the screen up. If there's a lot of material in your clay that's not passing through the screen, you might have to, you know, do this in smaller batches. So I just put the whole bucket through here. However, if this clay were sandier, it might have been better to just screen a few scoops at a time. So you can see there's kind of a good amount of material that did not pass through. I can just tell that a lot of this is plant matter, you know, a lot of roots and stuff, but there's also some really large stones. So what we do is we set these aside and we will look at them, you know, look at them later and try to maybe guess or try to look at them and see if they can kind of give us any hints as to what the clay's histories or origins are. I'm going to keep this bottom frame actually. So now I've got my screen slurry here. And I could just leave this to dry. It would just take an incredibly long amount of time. So I'm actually going to transfer this into another container. And this container is going to allow the fresh water to pass through. And then that water can be collected and reused later. And then this clay will set on top. And once it's dry, that's our workable clay. So again, this is a great opportunity to use these wooden screens. We just kind of place these over the container. Your crushing machine here. And then we're going to line this screen with just an old bed sheet. You want to make sure that it's a fine enough weave that it's not going to you know, allow all of the clay to pass through. And you want to make sure that it doesn't have a bunch of holes in it too.
This may seem like a silly question, but is that an entire bed sheet just folded up then? Just so we know roughly how many layers there are?
Yeah, I would actually recommend just using one layer. I have this folded just because we actually use this screen for a much larger drying rack. This particular rack, I could cut this sheet into 3 pieces. But yeah, one sheet is fine. If you want to be extra careful, 2 would be fine as well. But the thicker this cloth is, the harder it is for that water to pass through.
And then turn.
Oh yeah. So Zoe's just kind of set this wood here so that we can get the whole trough over the container and then nothing spills out. I need that scoop. You took this. So then for this, I'm just going to ladle the material back into the container. An option to save time would be to actually screen your clay directly into this trough. But what we find is that, there are occasionally mishaps and screens do break or things do spill. And so we like to make sure that we're not going to jeopardize a whole batch. Because remember, we're screening, in those trash cans most of the time. All right, perfect amount.
Yeah.
So that's kind of this particular system. The fresh water is then going to drop down through the mesh, collect in this container. That can then be reused. An alternative is to use these bisque-fired bowls. So we just have a lot of these bowls sitting in the studio. They've just been fired to bisque temperature, very sandy clay. And we just line these with a bed sheet. And then we fill this with clay, and then we'll actually fold the sheet back on top. So that kind of wicks the moisture up to the surface. And then we have a fan that kind of blows air over it. So it's kind of like a constant evaporating process. If you can get a bunch of these out in the sun, that's even better. Just kind of save the energy and let the sun do the work.
Mm-hmm. We like to line it with that bed sheet because then once your clay is mostly dry, you can just pick up the bed sheet part and pull it out of the mold and maybe lay it on a plaster pad or something like that. So it makes it a lot more mobile in that way.
Yeah. So again, this is just our perspective, our technique. People throughout the world for hundreds of years have been doing this in very different ways that are kind of unique to their processes. So we encourage everybody to kind of, dive deep and see what other options are out there. But yeah, this is kind of what we found works well for us. So this dries in the studio. This consistency in our studio usually takes a week. If we could get this out into the sun, it would probably speed it up a little bit. But then once it's done, that clay is workable. We can either work with it in that natural state or wedge in sand or materials, or combine it with other clays that have been prepared, which is what we're going to do next. So I think we'll flip the camera around. I'm going to wash off my hands, and then we can take a minute or two for some questions if anybody has any.
So the processing process is pretty simple. It's really straightforward.
Yeah.
But if anyone does have any questions before we move into blending, we'd be happy to answer some.
Do you think you lose any soluble minerals when you use that process where you're collecting the water underneath rather than it evaporating from a bisque mold or a plaster mold?
That's a good question. I haven't really thought about that, but I'm sure there is some loss of the solubles. Yeah. So if you're working with a clay that has, you know, certain solubles that give that clay a lot of beautiful character during the firing, it might be better to work with it in a way where you don't extract water and thus extract the minerals. What do you think, Nancy?
It's just I heard it for wood firing. I think it was during my training, but I've not actually tested it or tried it to make a comparison, you know, so it was just whether you had noticed any difference or, you know, whether it's a myth or...
Yeah. I think if you were to dry the clay out completely, you would probably, all those solubles would then, you know, evaporate or migrate. But I imagine there would still be some left, but I don't know. Maybe it's like washing wood ash. You know, you do remove some of that material. I don't know.
Also, sometimes you get like these chewy lumps, which are really hard to dissolve, you know, to slake down, or you're just scrubbing at it on the sieve, you know what I mean, forever trying to get them to go. Have you got any, you don't have any magic tricks for dealing with those, do you?
Yeah, that happens all the time.
That happens a lot.
With the ball clays.
Yeah, I think that's one of the reasons why we actually started drying the clay before slaking it, because if the clay is thoroughly dry, I know that sounds kind of counterintuitive, but if it's thoroughly dry, and then you can crush it up to a finer size before putting it back into water, then it can help the clay to absorb water more consistently. Because I have noticed that with ball clays, if we have a chunk of ball clay and we just get kind of lazy and we don't crush it up, it's so tight that it just doesn't absorb water properly, and it doesn't become a liquid. It just stays that kind of gummy consistency that you were talking about.
It's just interesting that some of it slakes down and then just there's some residual lumps that just refuse to. Do you know what I mean? It's a bit...
Yeah. Sometimes we'll take that lump, you know, that it's usually like this much clay at the end. We dry this out thoroughly and then just go through the whole process again, you know, crush it, slake it down, sometimes with hot water. Hot water usually helps it break down faster. But yeah, just try to get as much clay out of it as possible.
Yeah, we do wash our screenings. So that stuff that was left in Mitch's mesh that he just kind of like lumped up and put to the side, we would probably soak that again and do it again just to try and get all that good stuff off of there.
Yeah.
Have you experienced that the more you process the clay and the finer particles, the lower the melting point?
You mean if we process it too much?
Yeah.
That's a good question. The finer you screen something, the lower the temperature it will fire to.
Yeah.
But that being said, it's for the most part a nominal change in temperature. Like you might
very small.
Very small. You might notice a little bit of glossiness on the surface if you screen it a little bit more, but it's not like screening it an extra few mesh sizes will turn it into a puddle. Usually,
okay.
Happen. So, great question.
So you're saying it won't change an entire cone firing or anything like that? It'll just change a little bit of the sheen on it?
Yes.
If it's typically. So usually clays like this, if you screen them, you know, progressively finer and finer, there might not be that much difference in the final firing temperature. But this primary kaolin, it is so high in quartz and like chunky pieces of silica that if you remove that, this clay no longer has such a high silica content. And so if you remember, this clay when it was fired was kind of like a, just felt like a soft brick. It was extremely porous. If we took this clay and maybe screened it to 220 mesh and then fired it again, maybe it feels a little bit more porcelain-like, where it's a little bit more glassy. So we've removed that extremely refractory and coarse sand, and we're left with just the clay, which will probably have a lower melting temp. Yeah. So it's more effective with
coarse clays.
Coarse primary clays. Good question.
Yeah.
I love that.
Okay, so we're gonna segue here now because we just have an hour left for today. The time is really flying by, but I'm gonna briefly introduce a testing technique, basically the most basic testing technique possible, and then we'll actually execute it to make a line blend for a clay body. So the most basic blending technique you can do is just blending two different materials, or otherwise known as a biaxial test. So
that's a different one.
That's different?
Yeah.
Okay, never mind. Forget what I said biaxial. It's a line blend. It's really just blending two different materials in a line to get a nice gradient, both of colors and working properties and melting temperatures. So whenever we demonstrate this test, we like to use two clays with very different properties, and it can really help you see the difference in the gradient that comes up between them. But you don't have to use clays with two such extreme properties. You could use, two primary clays if you wanted, or a primary clay and a stonework clay, or something that's a little bit closer on the spectrum. Yeah.
A good way to think about it is to just approach this whole thing with a goal. So if my goal is I want to achieve a plastic workable clay body, a good way to achieve that is to combine a clay that has very little plasticity with a clay that has too much plasticity. So too much plasticity, it's a tough word. Too much plasticity makes it waxy and dense, kind of difficult to work with. Coarse, obviously. So by blending these two, we're going to find a nice balance. If your goal is to find a clay that is vitrified at a specific temperature, take a clay that has a very high temp and a clay that has a very low temp, and then the line blend is going to show you the gradient, and then you can choose which one is best for you.
Yeah. You can also use this test if you have just one sample of local clay and then a commercial clay. And that's great because if you don't have a whole lot of access to your native or your local clay, it can help you stretch that clay a little bit further by blending it with a commercial material. So it'll make it last longer, and you can have a larger batch of it in your studio that way. Or you could use this technique to do slips or color tests using mason stains, which we're not going to cover, but we'll cover making slips using a lime blend tomorrow, first thing. So whenever you're making tests in the studio, the most consistent way to measure your materials is in the dry state by weight. So by using a little scale like this. When I'm saying dry state, I don't mean dry like this dry, I mean like powder dry. However, Mitch and I like to avoid using dry powders in the studio as much as possible. So whenever we're mixing clays, we prefer to do it in either a wet slurry state or even a workable clay state. And when we mixed clays in the workable clay state, we still use the scale and measure them by weight. We just try and get 2 clays with similar consistencies. That way we know the water content is probably similar. If we are blending materials using wet slurries like we'll do tomorrow, then we typically measure by volume at that point. We're not measuring by weight anymore. We'll get into that more tomorrow though.
Yeah.
So for now, I'm gonna share my screen just for a second to show you a visual diagram of what we're gonna be doing with this blend. So this is really what we mean when we say we're blending 2 ingredients. So on one side, Mitch is going to be working with that refractory ochre clay, and he's going to be measuring out first just 100 grams of that clay by itself. And then on my end, I'm going to be measuring out 100 grams of the red clay, like you can see on the right-hand side here. And then gradually, each of us will be measuring smaller and smaller increments. We're doing 10% increments for this example because it's easy, and it's extra easy when we do 100-gram batches. And once we have all of our little pieces weighed out, we're gonna wedge them together really well until they're consistent. So let's stop that screen share. Okay. So yeah, we're just measuring our pure samples and keeping track of which one is which.
So we should mention that we are doing these tests right now with clays in their pure state. And normally by the time we get to a point where we're blending these to create a clay body, we will have made the decision if we're going to work with these clays pure or if we need to screen it because of limestone. If you remember this greenish kaolin, it did have some limestone pop-outs in it right there. So normally what that means is we kind of have to assume that, you know, if that sample has limestone, then all of the clay can have limestone in it. And so by the time we get to this test, we would have screened this, dried it. And so we know that, you know, there's not going to be any contamination of limestone in these tests. But just to kind of show the variation between a really coarse and a really waxy clay, we're just going to do it in the raw state.
We really need 2 scales when we're doing this.
Goes fast with 2 people though.
Mm-hmm. We're almost done. I know this is tedious to watch.
Do each of you have a favorite part of the process?
Yeah, I really enjoy actually being out in the field, collecting the materials, kind of seeing how they exist in nature. That's always like the big inspiration, you know, bringing it back into the studio. How do I make something with this material that references the environment that it came from?
I honestly like making things better than I like testing them. I do love when we have a bunch of tests and we open up the kiln for the first time and we get to see how different blends have changed. I mean, that's always like such a treat, you know, to see. And sometimes we get really unexpected results too.
Mm-hmm.
So.
Mm-hmm.
that's really lovely.
Yeah, we kind of find that, you know, because we live in a place where the seasons really affect how we work, what we're doing in the studio changes throughout the year. We're much more excited to get out and, you know, look for materials in the spring and the fall when it's nice. In the summer when it's, you know, 100 degrees, obviously not as interested in that. The same goes for winter.
We have very extreme seasons here in Minnesota.
Yeah.
So I'm bringing the clay samples a little further back on the table so you guys can see them. So this is Mitch's 100% sample, and this is his 90%, and it gradually gets smaller. So I'm just going to match up my opposite measurements with his. Yeah. Something's not right. Oh, here, this one. No, everything. We did this last time too. I missed one. Okay.
Coordination. That looks right.
Yeah, this is right.
Okay.
Okay. So now I'm keeping this one pure, and I'm just gonna begin by blending the middle ones here. So another reason this is not the most efficient way is that it can take quite a bit of effort to thoroughly wedge these little tiny balls of clay.
I can't even wedge this clay.
Yeah, Mitch has the short end of the stick over there.
Short end, short clay, short end of the stick. That's funny.
But we find that when you're blending clay bodies and you're doing these 10% increments, even if you're not super precise with your weights, you can still see a nice gradient after it's fired, and it can still give you quite a bit of information. If you want, after doing this initial test of 10% increments from 100 to 100, you can always kind of narrow in on a certain range that looks promising to you. And then you can be more precise with your next measurements. But when you want quick results, this is a great way to do it.
Yeah. One thing that's kind of happened with our, you know, approach to testing and then preparing clays is that we do these initial tests, these little blends like this once, and we find a ratio that we really like. And then instead of processing each clay separately, we just process them at the same time. So we say, you know, we will maybe do these tests in a dry state, which, as Zoe mentioned, we don't often do, but do it in the dry state. And then if we like a certain blend, we just, you know, put that same ratio of clays into that large barrel and just slake them together, screen them together, dry them together.
Makes so much more sense. And then you have a very consistent product.
Yeah. So combining these as a slurry is going to be much more efficient than wedging them like this. If it was a slightly larger amount, we could, you know, maybe do some more thorough hand wedging or even foot wedging, which would be great.
Yeah, mine is getting a little dry too. And then of course, every time you wedge a material, it dries out on you just from being moved around in the air. I'm seeing in the chat that you guys really want to be touching clay right now. I'm so sorry. I wish you could be here with us. It would be so much fun. How's it smell?
I don't have the palate.
It smells like rust. It smells.
Yeah.
It smells very metallic to me.
Yeah. So the red clay definitely smells like like iron. I've always kind of felt like a lot of clay smells like, you know, it smells like a pond.
Like frogs.
It smells like frogs. So that's just kind of become a thing. And there have even been a few unfortunate events where frogs have decided to take shelter in my clay as I am drying it out, and unfortunately suffocate, which is tragic. Yeah.
That's when we lived in California and we dried clay outside.
Yeah,
it
that's
has
true.
its benefits and its drawbacks.
Yeah, we were in about an hour and a half north of San Francisco, kind of just north of Napa Valley, up in the mountains. Very hot, very dry, and so any source of water just kind of became an oasis for all of the critters. And so when we left our clay out to dry outside, it would just kind of attract everything. So we'd see little paw prints, you know, different things just kind of working their way through our clay.
Yeah.
I love that. Kind of miss it here.
Yeah, it's very different working in a city studio. When we first moved to St. Paul, we had a studio in an office building in downtown St. Paul with no freight elevator or anything. We had to move like under the cover of darkness. We would go into the office building at 10 o'clock at night with all of our buckets of clays and raw materials to go in the elevator. It was so ridiculous. Not good for a ceramic studio.
It was a first step.
Yeah.
But Elisa says birds always poop on my clay when it's outside.
Yep, baby spiders in your pots. We get a lot of little plants, little volunteer plants from seeds that that don't get screened out of the clay because they're so small. So sometimes I'll be working on a piece and it'll be just under plastic for a few days, and the warmth and the moisture from being under that plastic will cause the sprouts to grow.
So as you're making these tests, this is a good opportunity to see at what point, ooh, a big stick, at what point the clay becomes workable to your taste. So this one I just wedged up. This is 50-50. So 50% of both clays. And it finally has enough plasticity to feel like it's something that I could work with, at least in the normal way that I work.
Mm-hmm. And it's funny that Mitch says that because I actually prefer this clay, which is 70% red clay, so a little bit more of the really waxy clay, and 30% of the really gritty stuff. And so we have different tastes in the studio.
Yeah.
Whenever we go out and collect materials, we collect them together and we process them together. But then we also test them together. But usually at that point, when we are deciding on specific recipes that we each use, Mitch and I will kind of branch off and do different things. He tends to prefer clays that are a little bit sandier and have more texture to them. And I like clays to be just a little bit more workable.
Yeah. Yeah, just kind of a nice, I'm always seeking that balance, just enough plasticity to make it workable, but enough texture to make it interesting. So be curious to see how that blend fires.
Mm-hmm.
What shape are we making?
Test bars.
These, roughly?
No, I prefer the other one, I think. Could you bring that board here?
Yeah, just give me 1 second.
So it's a good idea if you see that you're starting to lose track of what number is what, to label them as you go, even if they're not in the final shape yet. You know, just put like 10 or whatever helps you remember what's what.
Yeah, or even just having labels written out on a board.
Yeah.
That's something that we often do. We like to use these sheetrock, just pieces of drywall that have been cut, and then we very thoroughly taped over the edges to make sure that the loose gypsum doesn't get out and get into the clay because it's calcium carbonate. But it's great because it absorbs some moisture, and so the bottom kind of dries out. We can write notes on this if we need to, and then just wipe it off pretty easily. And these are great because unlike wood, these do not warp. So if you're making, like big plates or something and you want to keep the foot flat, we'd really recommend, this drywall, and it's cheap.
And it draws out moisture.
Yeah. All right. So you can kind of see already there's a bit of a color gradient, It's pretty subtle because both of these clays have a little bit of iron, or they have a considerable amount of iron in them. If we would have done this with that white primary kaolin, obviously we would have had a more, diverse gradient.
Mm-hmm.
Do you want this?
Yeah. So I can't remember if Mitch said it, but we also like to use these because they draw some of the moisture out of your clay, so they won't stick to your clay as much as this like polished wood will.
Mm-hmm. Did somebody just have a question? I thought I saw the screen pop up, but I wasn't able to see whose name was on there.
Oh, it was me, Ginny. I think I don't really have a question. I was just curious about, if you were looking to add, to find something to add to porcelain, to add plasticity to it, I guess, does it just come down to looking for something that another clay that is maybe not so dark, right? But yet still has a more plastic texture. If you don't want to sacrifice the much of the color.
Yeah. So the main way to kind of approach that is to add as little as possible. So with that, you want to find something that is, packs the biggest punch in the smallest amount.
Right. Okay, that makes sense.
Yeah. So in terms of commercial materials, normally what people would add is bentonite, and even just by adding, 2 to 3% bentonite, you can significantly improve the plasticity of porcelain. When you do add bentonite, it's recommended to mix that particular clay into a slurry and let it fully absorb water before adding it to your other porcelain. Are you working with like, are you making your own porcelain or using prepared?
No, definitely not. In fact, I do use a porcelain with bentonite. And it's a little bit off-white, but that's okay with me. I don't need any kind of pure white, frost white or type, but I guess I was just looking to explore other other options for making, working with porcelain for hand building.
Yeah. So I think Zoe kind of approaches that.
Yeah. So what I do a lot when I'm blending porcelain with my local materials is I try to blend porcelain with a really workable clay on its own. So I use, I typically blend in some lighter colored ball clays with my porcelain. And those I harvest here in Minnesota, but you can also find some kind of white to cream firing ball clays at a clay manufacturer that you can add to a porcelain clay body to make it just a little bit more workable too.
Yeah.
Got it. And so I never thought about just adding a tiny bit. That makes sense. Just trying, you know, like with this kind of grade,
yeah,
kind of graded test approach. So
Yeah.
that makes sense.
Yeah, you would probably see pretty significant changes in the plasticity, you know, between 10 and 25%. You know, you might not need to add more than 25%. Ball clays are just very effective at making things really workable.
Mm-hmm.
Do you match shrinking states ever, or do you test them again?
Could you say that one more time? I think part of it cut out.
Do you match shrinkage rates at this stage? Or like, do you match shrinkage stages when you blend the clays, and then after, you know, the different percentages probably react differently, right?
Yes.
Yeah, when they're so if you have a clay that shrinks 5% and one that shrinks 15%, by blending them together, you're going to achieve an average of the two. I think it kind of depends on a few factors. What do you think, Zoe?
Yeah, I guess it also depends on how much sand just happened, or sand and other grog happens to be in each sample.
Yeah.
But
at this point, we're not so concerned about one shrinking more than another. Yeah.
If you blend them thoroughly enough, they will have a new shrinkage rate that's like that blends shrinkage rate. It's not like one of them will shrink more than the other and they'll dissociate. If you just marble the clays and you don't blend them thoroughly, then you might have an issue where one of them will shrink more than the other, and then you'll get some separation where they've been.
But when you get into slips used as glazes, you take that into account, yes?
Yeah, at the slip stage, it becomes more critical, because that's, you know, when you have a slip that shrinks more than your clay body, you start to get that fine crackling, and then eventually it just flakes off. So yeah, at that stage, it kind of becomes hard. So if you have like a really really porous clay that doesn't shrink a lot, and you put a porcelain slip on it that gets kind of glossy during the firing, chances are it's probably going to have a little bit of cracking. So to balance those shrinkage rates, you would either make the porcelain slip more refractory or make the clay body
more fluxed.
More fluxed, yeah. So yeah, if that kind of makes sense.
Do you want to label these? That's right.
Yeah.
Any other questions that people have right now? I know this is, you know, you're just watching us press these little tiles, but we're happy to answer questions.
Do you guys have any sort of suggestions as far as keeping track of where you find clays? Because I'm sure it can be a little difficult sometimes, because I you know, even 10 feet apart can be drastically different. So how do you go about, you know, sort of, I know everybody needs to find their own process and everything, but could you just speak to that a little bit maybe?
Yeah. Whenever we're out in the field, I know this sounds like a very basic answer to that question, but we do take a lot of photos of the clay pile itself, but then also like the clay in its setting. So we can kind of keep track of where it is for the next time we go. We do, now that we've been established in Minnesota for a few years, we do have a few places that we return to year after year. And, you know, each time we go, we have to remember like, oh, it's past this hill near this little bush, or, you know, like it's literally very basic the way that we return to our clay piles. But yeah, taking notes, taking photos. Do you have any other tips?
Yeah, sometimes if you're in an area where you have a little bit of cell service, you can drop a pin on a map using Google Maps. And that way you can actually get to a very specific, what do you call that? Coordinates.
Yes. Yeah, and we do that quite a bit too. I think Mitch does it mostly with his phone. To be honest, I'm not as tech savvy and I don't know how to do it, but
it's important to just remember that, although you can return to the same material time after time, that material is going to change, especially if it's in an area that's exposed. The question came up earlier, if you were to screen this clay down and remove the sand, is that going to make it vitrify at a different temperature? Nature does that all the time. So one of the clays that we have is just kind of sitting in a pile out in the middle of this field. And so every time we go, we find that the fine particles have just been washed away more and more. And so what's happening is that this clay is actually becoming more refractory because the fine particles are no longer in the mix, which is kind of an interesting phenomenon. But it's poetic. I think you sort of respond to these materials in nature and as pieces of nature.
So then you're definitely retesting those same spots every year to see the changes.
Yeah.
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 Yeah, because I've seen other artists that I guess they have their own land and they dig in the same spot every year and they dig once a year and they don't seem to test every year, which kind of blows my mind.
Yeah.
And I don't know if it's just because it's more protected or, I mean, every location is going to be different, but I don't know.
Yeah, I think it just kind of depends on the deposit. If it's a really abundant deposit and it looks like there's not a lot of variation throughout it, it's probably going to be more uniform time after time. But a lot of what we're digging is, relatively thin layers, and like one layer is very different from what lies beneath it. And so, there's just a lot of variation that way. Yeah.
Plus, I feel like we're just always testing anyway, just because we have so many like small samples of things that we're not sure what to do with. And so it's just a constant process of trying to test those and find new uses for them. So if we're testing things anyway, we might as well test the large batches of clay that we use too.
May I ask a question going back a little bit to earlier, talking about primary versus secondary clays? So the granite deposit that we have is near a river. It is a glacial deposit. So it's not necessarily humid and all that you described, but it is on the water. So would you expect to find primary clays below that deposit?
I think that you almost have to, so because primary clays take so long to form, you almost have to consider those conditions millions of years ago. So the question is, the location where you stand now, where was that on the globe, 100 million years ago when this granite was being decomposed into clay? Most of the United States was fairly close to the equator, which is why there's a good bit of kaolin throughout throughout the country here. I think the best way would probably be to ask a local geologist. Just say, I'm looking for kaolin, and I wonder if there's any kaolin that could be forming from this granite.
Yeah.
They would definitely know.
Because what's interesting is, so that is up on a ridge, and below the ridge is the water's edge with big mud flats. Which, of course they're brown, they're not white, but it could be stained. but it is up in New England. And I guess what I have maps I've seen in the past that primary clays in the United States tended to be down, more south at mid-Atlantic, Carolinas.
Yeah, Florida and Georgia, I think, have the biggest deposits of primary clay in the US. And that is just because they are sitting at the intersection of all those things. It's warmer, it's wetter, and there were a lot of granite type rocks there.
Yeah.
But it does exist, throughout the country and throughout the world. However, it's just not existing in deposits that are economically worth investigating, if that makes sense. So like a large clay mine isn't going to bother if there's a kaolin pit that only has a couple hundred tons. They want a lot.
Yeah.
So you might have something there. Yeah.
Yeah. I'll have to explore.
Yeah. Keep us in touch. We're curious about that.
Yeah.
Okay, so we'll just kind of share our finished line blend here. I forgot to label the rest. I was chatting. But yeah, so we'll dry these. We'll put them in each in their own little safety trough, and then we'll fire them. We actually have fired this blend to kind of show you what this result looks like.
And so I just know these are going to slide off if I try to hold it up. But this is the same blend fired to cone 6 in our oxidation kiln. The raw yellow kaolin, or the kind of like crumbly yellow clay that Mitch was working with, is on this end. And then the really waxy red clay is on this end. And so you can see this is that sample we were showing earlier where the clay just melted into its test boat. And this is the other sample we showed earlier where there was a little bit of limestone pop out, and it's very porous and under fired at that stage. So by blending those two clays with very opposite properties, we've kind of developed a nice happy medium here in the middle, where many of these clays could be possible to use in your studio depending on what you want to do with them. So here, Mitch is going to hold that. You can see that it looks like maybe these 3 clays here, they still look pretty porous to me. If I were to drop water on them, I think the water would absorb almost immediately. There's really no glassiness to them. They're very dull. You can even hear how dull it sounds compared to one of these. So that was the dull, and this is a high-pitched one. So if you kind of flick it or tap it with something else, you can kind of get a sense for how vitrified your clay is just based on the sound of the clay. So these look pretty porous still, not vitrified enough. You could still use them for a sculpture clay body if you wanted, but just keep in mind if you were to use this for any food application, it would absorb any liquid, including oils that you put on the surface. So maybe not a great idea for food application. On the opposite end of the spectrum, let's say these 3 clays here, I'll kind of pull them up so you can see they have quite a bit of a sheen to them. They definitely look a lot glossier, more like glass than that side. So this one has even more. And this one's really bloaty, probably almost stuck to its test boat. So yeah, really shiny. So, you might be interested in using one of these too, because it's basically a clay with its own glaze mixed in because it's so glossy on the surface. This one I would hesitate using because I have a feeling it would lose its shape if you made a really large piece to fire. And actually that's a good point to mention now. Once you do this line blend, after you have these results, you might want to retest the same clay in a slightly larger batch by making a little piece with it. So making a bowl or something with some kind of vertical walls to see if that slumps or changes its shape at all during the firing, because really glossy clays tend to get kind of wonky. Now, if we look at this, let's see, this middle section here, these three, these really look like the cream of the crop. The color is really interesting.
Show the back of that one.
Oh yeah, this one has a lovely texture to it. Really, like, this is a really nice brick red in person. And then this one's a little bit more chocolatey in person. And it just makes sense that these would be the most ideal, because we were using two clays with such extreme properties, that the middle should be kind of what you're aiming for, I guess. So the one that's 60% kaolin and 40% red clay, 50-50, and then the one that's 40% kaolin and 60% red clay. These look like the most promising tests to me. But like I said, you could use something from all over the spectrum. It really just depends on how you want to use it.
Yeah.
So more food safe on this end because they are a little bit more glossy. You could apply a glaze or maybe refine the surface of these a little bit more if you were to use them in a food application. So that could mean sanding the surface really well. It could mean screening out some of those sand impurities to make it a little bit less porous. But then if you wanted more of a sculpture clay body, you could certainly use the middle section here, because it would have great working properties, really good plasticity with just enough grit to make it interesting. Or you could make a sculpture clay body from something on this end, because you're less concerned with it holding liquid or being food safe. You don't have to worry about it being porous. So you have some really interesting color variation on this end. Yeah, anything you'd like to talk about?
So, again, these are just our materials. You might blend different things and find very different results. This range of 60%, 40% to this other one, which is 40%, 60%. Your materials might, they might not look good in this range. They might look better over here. So you're not going to have the same results, but you have all the information you need to kind of figure out what's going to work for you. So that's what's really exciting. This applies to materials all over the world.
Yeah, and if you use materials that are not so opposite, you're probably not going to see the happy medium in the middle. It'll likely be elsewhere on the spectrum.
Yeah. Yeah, I mean, Zoe mentioned slips. This is kind of a great way to develop specific color palettes for a slip. The only difference is that you would take this clay and you would obviously just wet it down to the consistency that you apply it to your piece at. And then that way you have a surface of this color and you don't have to use all of the material. If your material is very precious, you can just use it more sparingly that way.
Yeah, that's a good way to stretch out a very small quantity of locally sourced material. Is just turn it into a slip and just use it on the surface of your work.
Yeah. So I'm gonna just quickly run through these and just see how the different blends shrank differently. This first one, I think we talked about, it shrank 1/4 of an inch. This one is 70% kaolin, 30%. So this shrank just a little bit over 1/4. 50-50 shrank 1/2 inch. So you're starting to see that as the clay becomes more vitrified, it shrinks more. So there's kind of an interesting relationship. As we get down to this far end where it starts to melt it actually starts to increase again. So 50-50 had shrank 1/2 inch. This one is only 20% kaolin and 80% of the fluxing clay. And that shrank closer to 1/4 inch. So it's actually starting to expand as it bloats and begins to melt.
Yeah, which makes sense when you see this test bar. It's
Yeah.
actually bigger in surface area than this white one because it started to expand a little bit. So since we just talked about some test results, I'm actually gonna put a poll up, and this poll is really just asking people if they're interested in sharing something from their own studio at the end of tomorrow's session. When we are asking you about something you want to share, it could really be something from any stage in the process. You can share, just a raw material that you found and you don't know what to do with it yet. You can share a piece that's in progress. You can share some tests that you've done. You can share a finished piece or photos, really whatever you want.
Yeah. Can be something you're proud of or something that maybe didn't work out so well and you're just kind of amazed by how it went.
Yeah. Yeah, so just take a few minutes, let us know, and it'll give us a head count for tomorrow. I'm just gonna leave that up for a few more minutes. But if anyone has any other questions about line blend tests or anything else, we can answer those.
Yeah.
Do you have an idea about what time you'll start that last piece, the sharing part?
I think it's the last hour of tomorrow.
Okay.
So I can't remember. Are you on the East Coast of the US?
I am. I just, I may come in late to the class tomorrow.
Oh yeah. So it'll be, I think, 4:30 your time tomorrow. Because
that's great.
3:30 is a half an
4:30 your time is 3:30 our time. So yeah, that's the last hour of the class.
Okay.
Yeah. Yeah.
Perfect. Thank you.
Mhm.
Yeah.
I had a question about your firing. You guys keep referencing that you use oxidation kiln. Is that out of preference, or have you found that it has a specific effect on the raw clays that you use?
It is.
A lot of things.
Yeah, it's become to be out of preference, but it did not start out that way. I think I mentioned earlier, we moved here to Minnesota from California a few years ago. And when we were living in California, we fired almost exclusively with wood in wood-fired kilns. And we really fell in love with that kind of palette that you get from firing in that kind of atmosphere. And we knew that by moving to Minnesota and not having consistent access to a wood kiln, that we would have to change the way we work. And so when we first moved here, first things first, we located our clay resources and began testing those. But really, we just anticipated doing all of our work in an electric kiln because that's all we had access to. We would love to be able to try some of our clays in gas-fired kilns to see how they respond to reduction atmospheres, but just by way of where we're located and our studio setup, it's not possible to run a gas line in here. But that being said, you can really develop your clays to fire in whatever kind of kiln you want.
Mm-hmm.
They're super flexible to kind of manipulate.
I think both of us have kind of approached the challenge of moving from wood firing, which basically generates an interesting surface, to a firing process that normally does not generate such an interesting surface. And we have to work a little bit harder to find ways that sort of keep the spark and sort of keep us excited about materials. And there's just been something refreshing about, working in oxidation and sort of pursuing that. And it's led to such a wider understanding of materials and what happens when they're blended together and, you know, layered in different ways. So it's been a huge challenge, but I think it's, like Zoe mentioned, it's finally becoming like a preference. We think about wood firing and we're kind of like, I don't really know what clay I would make. I don't
Well,
have
it's
any clay.
interesting because the oxidation is more of a control. So like you're saying, then the results are predictable and, you know, with the wood, I mean, I'm reiterating what you're saying. It is very interesting though, how positive it allowed you to go so deeply into this material analysis, which the wood firing would not have been scientific that way.
That's true. And unless you have access to your own kiln and you take like rigorous notes about the firing and where you load certain things, you're absolutely right that it's very difficult to have that control aspect when using a wood kiln.
There is a good bit of science behind, you know, wood firing, the decisions that go into wood firing, but there are so many more variables that can affect the final outcome. You know, even if you know, are a seasoned veteran and you fired your kiln hundreds of times, you know, there's always going to be something new that happens. Yeah, it just sort of puts so much more importance on really looking at the material and wanting to showcase it and really honor it.
Wouldn't firing and oxidation be a great starting point for all these tests that you've done, and then going to atmospheric would just add more, you know, depth, or, you know, it'd add another layer, but it wouldn't change the shrinkage and the absorption and all of that, unless you added salt or something like that, wood ash. But reduction, would that just not?
So you're right that firing and oxidation is great because it's like a blank canvas, but then any other types of atmospheres you fire in will add an extra element to the work. But I don't want to say that that it's not going to change the shrinkage or anything like that, because even if you fire to the exact same temperature in a gas kiln as you do an oxidation kiln, you will likely get slightly different results when it comes to shrinkage and absorption and definitely in color. I mean, I think you all know that if you fire the same exact clay to the same temperature in oxidation and reduction, the color will be dramatically different.
Yeah, I think a lot of it comes down to both the atmosphere and the rate of temperature climb during the last couple hundred degrees of the firing. So in an oxidation kiln, you can control how fast or slow the last, you know, 200 degrees go of the kiln. In a gas kiln, that might go a little bit slower. And so firing slower at the end of the firing generally vitrifies the clay more as opposed to firing faster. So that's kind of also something that comes up with wood firings is often you fire up to a temperature below your desired goal, and then you kind of hold that temperature and maybe very slowly increase it until, you know, until the cones that are in the kiln begin to melt. So there are a lot of subtle variations, but yeah, I think it would be so wonderful, as you mentioned, to just see these in a new light, a new atmosphere. Yeah.
Okay. Anything else you guys want to talk about for the last 10 minutes of class today?
At the beginning, you had said that only 30% of clays is like pure clay or something like this, you know, at the very beginning in your presentation, and that, you know, you have all these other sort of subcategories of clay, like loam clay. So when you showed that, was it secondary kaolin, for me, not knowing where it came from, I thought maybe it could have been like a loam clay. So how can you, if you're not familiar with the surroundings, how can you distinguish between, you know, these different categories of clays?
That particular, I think it was like 10 to 20% is only what's used, and the remaining 80 to 90.
I think, are you referring, you were talking about the soil triangle, right? And I think I said something like, if you find a material that looks like it's more 30% clay, but maybe I can't remember, like 70% silt. Like, how do you determine that? Is that what you're asking?
Yeah, or if somebody brings a clay to you and they're not familiar with the surroundings, how do you determine whether it's like a secondary kaolin or it's a, you know, clay with a lot of soil content, you know what I mean?
Yeah.
Content in it.
Yeah. A lot of it, you know, knowing where it came from is going to be a huge part, because it's, you know, this clay is a piece of this landscape, and when it's removed, you don't have all of the things around it that can sort of inform what it is, the context. But the actual like consistency of the clay, you know, if it's extremely waxy, like this red clay was, that's going to be at the top of that triangle, just like pure clay. If it's like a, you know, obviously pure sand, you know what that would feel like. So somewhere in between those two is that sandy clay. Silt kind of has this interesting, it almost just feels powdery. And so I think like as soil has a lot more silt, you know, just that fine sand material, that's what they call loam. And so I think just kind of becoming comfortable with that, it's almost like jiggly, you know, the more you move it, the more it just kind of like falls apart.
It has that thixotropic property anytime you have a material with really high silt content. So it's that property where it just wants to kind of turn into a puddle if you just jostle it slightly.
Yeah.
So
what would be interesting to do is to kind of recreate that triangle with a wild clay, a wild sand, and a wild silt, maybe collected from a river, and then do a triaxial blend. And then that way you can really feel what, you know, what a loam clay feels like that has a lot more silt compared to, you know, a sandy clay.
That's like a crazy idea.
Yeah, because I feel like it's the middle of that triangle that gets really confusing. You know, we know what clay is, we know what sand is.
Yeah. And just don't even fire it, just to like have samples of what it feels like.
Yeah.
That's actually kind of a cool idea. We might have to make that.
And you know, when you get the different bands of clay, where some has got more clay than, you know, other bands. Have you ever tested those all, you know, next to each other?
We've been on the lookout for that, but we have not found any resources like that. So I had talked earlier about the different types of sedimentary clay deposits, and one of them was lacustrine. So that's when sediments are basically washed into a body of water and they accumulate at the base. Those environments often have alternating layers of very fine-grained clay, and then clay with silt, and then fine-grained clay, and then clay with silt. And those alternating bands are collectively called varves. Sorry.
We're going to put that word in the chat.
And so that just has to do with, you know, during summer seasons, there's a lot more water flowing. And so that kicks up some of the finer particles. And then, you know, that sediment that gets deposited is that silty layer. And then in the winter, when there's less water flowing,
it's actually, I'm sorry, it's actually the opposite.
Oh, did I say the opposite?
So in the summer months, the water tends to be a little stiller, but in the winter, there's more churning.
No.
Yes. Pretty sure. Does anyone here?
Because water is frozen in winter.
No, so, but it's trying to like, because there's warmer water at the bottom in the winter, so it's trying to like
equalize. This is just about what's brought into. You might be right.
Okay.
I'm sure you're right about that.
Okay.
I don't know. Maybe we'll look this up. But anyway, yeah, it would be really cool to test the differences in those specific layers. So you have summer clay versus winter clay. You know, how do both of those materials behave differently. You know, maybe one trims really beautifully that has a little bit more silt, but the other maybe is, you know, much more plastic and workable. Yeah.
Sometimes we have geologists who join us for these workshops. I'm not sure if anyone here is a geologist, but I always get slightly terrified that we're going to say the wrong thing and get called out on camera.
It's good. It's good to learn.
It is good to learn.
We're amateur geologists.
Yeah.
We have to make sure to mention that.
If we do say something wrong, please do correct us.
Yeah.
I wonder, the coastline here where I live is really really chalky. It's like chalky cliffs. Would you ever find, I mean, there's kind of like rivers around that I can look, but kind of along the coast where there's chalky cliffs, would you ever find clay around there?
Chalk is unfortunately one of those materials that it creates those line pop-outs. If you were to wedge like pieces of chalk into a clay, yeah, so it's a calcium carbonate material, and it can cause, you know, pieces to pop out of your clay, kind of like this, like the same thing we get with limestone.
Yeah. It is important to mention that the environment that chalk forms in is the same environment that shale forms in, and so, you know, chalk is just fine-grained, you know, calcium carbonate from shells and plant life that, or from
yeah, from like shells from
marine organisms.
Yes,
yeah.
and fossils and things. However, because chalk is so finely ground, it can make a wonderful glaze ingredient, and it'll just, you know, contribute that flux to a glaze, which is something we'll talk about tomorrow. We don't have any chalk in our area, but I would love to do a triaxle with some at some point.
Thank you.
Okay.
Awesome.
So yeah, just to wrap up for today, if you said yes or maybe to my poll, don't forget to bring something with you tomorrow for our sharing session. It'll be most likely the last hour of the class. So whatever time zone you're in, it's going to be a different time. Yeah, and you can just, it really will give people an idea of how much time they have when I go back and look at the results of the poll. So it might be 5 minutes or less. And keep track of any questions you get overnight. We'll start off the session tomorrow morning with just a brief question and answer if something comes up overnight. Yeah, we're gonna record, or we're gonna process this recording as quickly as possible and hopefully get it to you in a couple of hours. Sometimes it does take Zoom a little bit for these really large files to be processed, so bear with us. We'll send an email to everyone as soon as it is ready, and we'll also include the chat and the audio recording too, if you prefer just to listen to it. But yeah, that's all we have for today. We'll see you guys at the same time tomorrow. And I hope everyone has a really lovely evening or day if you're just waking up. So we'll see you guys later.
Thanks so much.